And during 6:30 to 7 means after the last session, whenever the speaker uh, ends the session, then immediately after there will be valedictory session. And during valedictory session, as I have mentioned in the group, that there will be um, examination link and feedback link will be shared. So please attend all the sessions, as well as please be present positively in the valedictory session, because the links will be shared during the valedictory session. So, and after that, for a significant duration of time, the links will be active to avoid any link or device related issues. So, as we have already announced that please complete the examination as well as the feedback come attendance link submission within the time as it will be mentioned clearly, without fail, because after that to activate the link may not be possible from the technical team. So with this, our distinguished speaker, Dr. Sriparna Shah ma'am, has already joined us. Welcome, ma'am, and a
Hi.
very good
Am I
afternoon.
audible? Am I audible?
Yes, yes, you are audible. Yeah. So, with the brief introduction of Dr. Sriparna Shah, the session 1, day 6, that is the final day of the FDP program, we are about to begin. Dr. Sriparna Shah is currently serving as an associate professor in the Department of Computer Science and Engineering, Indian Institute of Technology, Patna, India. She has authored or co-authored more than 400 papers. Her current research interests include machine learning, deep learning, natural language processing, multi-objective optimization, and biomedical information extraction. Her H index is 45, and the total citation count of her papers is 10,788, according to Google Scholar. She is also a senior member of IEEE ACM Fellow of IET UK, IETE. She is the recipient of Rashi Roy Memorial Gold Medal from the Indian Statistical Institute for outstanding performance in MTech Computer Science. INSA Young Associate 2024, Google India Women in Engineering Award 2008, Nasi Young Scientist Platinum Jubilee Award 2016, Bard Award 2016, IEI Young Engineers Award 2016, SARB Women in Excellence Award 2018, SARB Early Career Research Award 2018, Pattern Recognition Letters Editor Award 2023, prestigious Young Faculty Research Fellowship under Vishesharaya PhD Scheme for Electronics and IT for 5 years, that is January 2019 to January 2024, Fulbright Nehru Academic and Professional Excellence Fellowship 2024, Humboldt Research Fellowship, Indo-US Fellowship for Women in STEM 2018, Erasmus Mobility Grant Duo India Fellowship 2020, and CNRS Fellowship. Her name is included in the list of top 2% of scientists of their main subfield discipline, that is artificial intelligence and image processing. Across those that have published at least 5 papers, a survey conducted by Stanford University for consecutive 5 years. For more details, please visit the www.iitp.ac.in/Sriparna. That is the website address. So, and her talk is to be followed by this brief introduction of ma'am. And with this, over to you, session.
Yeah. Many thanks, Shparna, for inviting me in this FDP. So today I would just like
Welcome,
to
ma'am.
discuss about some applications of generative AI in the healthcare domain, because this FDP is on healthcare domain. So I just would like to discuss about how the generative AI concepts can be applied for the healthcare domain. Okay, so that will be my point of discussion. So as already it is introduced, like I am Dr. Sriparna Shah. I am an associate professor in the Department of Computer Science and Engineering, IIT Patna, and my email is sriparna@iitp.ac.in. And as a part of our research, we are also developing many tools and techniques for the Indian languages and also in the healthcare domain. So in my this talk, I will discuss about some of the tools and techniques for the healthcare domain, and those tools and techniques are available in my resource page. Okay, which is available at www.iitp.ac.in tilde /resources.html. So you can visit my resource page and you can download the data sets from my page. So let me start with the this generative AI. So what is, nowadays there are so many large language models are available. Like we are regularly using the Chat GPT, or now we have the DeepSeek models. So many models are available, and which are called the large language models. So why these models are called large? So these models are called large. Is there any comment? Oh, I don't. Okay. So these models are called large because they are trained on a huge amount of corpus. Okay, like I will show you the number of words used in the training data of these large language models. So large language models are the language models that are trained on huge amount of text data present on the web. Okay, and they can use the knowledge it has gathered during training to make the predictions and create new content. So there are many large language models available in the nowadays in the internet, and almost all the companies have developed their own large language model. Like Google has its own large language model. OpenAI is a startup which has its own large language model. DeepSeek has now developed its own large language model. So there are so many large language models are available in the internet. So basically, so what is large language models? So basically, you can see that why these are called large language models, because of the number of parameters or the number of tokens in the training data. Like if you see in the GPT-3's training data, there are 200 billion words, so 200 billion words are there in the training data. So that's why these models are called large language model. Yeah, so basically in the end, I will show you how these generative AI models can also be used in the agriculture. Okay. So basically these generative AI models are also having a very good knowledge in the agriculture. So I will showcase you on a past study where we have developed a chatbot which can give any kind of plantational related queries. Like if you will ask the chatbot any plantational related queries, like any question regarding the in-house plants, the chatbot will be able to answer those queries. Okay, so you can easily compare the size of these models. Like suppose there is a 13-year-old human being, maybe a 13-year-old human being has seen his or her lifespan only less than 100 million words. But BART, which is developed in 2018, has only seen in the training data 300 billion words. Robota, which is introduced in 2019, has seen it is having 30 billion words in the training data. And the GPT-3, which is introduced in 2020, in its training data, there are 200 billion words. So you can imagine how big the training data of GPT-3 is. And that's why basically this is called the large language model. So because of this large number of tokens or the large number of words present in the training data, GPT-3 is basically called a large language model. So you know that this is the history of the generative AI. So it all started with the generating the artificial or the fake images. So initially, the computer vision community has developed the generative adversarial network or the variational autoencoders. So they tried to understand the probability distribution of the images. Suppose there is a training data of images, and they tried to understand the probability distribution of those set of images, and then they tried to mimic those that probability distribution and they tried to generate some artificial images following the same probability distribution. So there is a generating the realistic images or videos through GAN or the variational autoencoder. It was in the year 2014 or 2015. Then natural language processing community was suffering a lot, and they were not able to understand the long context. So if there is a long sentence and they were not able to understand the meaning of the long sentence, like suppose there is a sentence like the chef who has worked for a long time in Delhi has now started its own business in Patna. So if there is such a long sentence, it's very difficult to understand the meaning of this sentence, and this is called the long context. And transformer models are developed in 2017, and which gives us the understanding of this long context. And then GPT models are developed in 2018 to 2022, and the GPT models are having billion parameter models, and they are the large language models trained on a huge amount of data, and they are capable of solving almost all the NLP tasks. And then nowadays we are having the diffusion models. So the diffusion models are text to image models. So you can give a textual description and you will be able to generate an image, okay, out of that. Like you can easily give a good textual description and you will be able to generate some images out of these models. Like we have daily 2, stable diffusion, all these diffusion models. So this is the history of the large language models. So as I mentioned that starting from 2019, almost all the companies have understood that they have to invest a lot in developing the large language models. Like Google has developed the T5, multilingual T5, Lambda, Flan, Palm, Bard. All these models are developed by Google. Then the Meta has its own large language models. Huawei has its own large language models. So OpenAI has also started developing the GPT-based models. So almost all the companies have understood that they need to develop their own LLMs. So and if they can develop their own LLMs, then it can solve almost all the tasks of NLP. So in LLMs are few shot learners. So basically, as LLMs are already trained on a huge amount of data, so basically you do not need a large amount of data to get a task from LLM. Okay, so the language models can be viewed as few shot learners in the sense that they can generalize to new tasks and domains with only a few examples. So for the LLMs, you only have to give a few examples, and with the help of these few examples, LLM can only solve the task, because LLM has a understanding, like basic understanding of the, has a very general, general common intelligence. So that's why whenever there is a new task, you only have to give examples of the new task, and from those few examples, it can easily start solving that particular task. So this is because language models are trained on a large corpus of text data, which provides them with a general understanding of the structure and patterns of language. When faced with a new task or domain, a language model can use this general understanding of language to learn from just a few examples. So there is a term called the in-context learning. So in-context learning is a type of learning in which a LLM learns to accomplish a task after seeing only a few examples, despite the fact that it was not trained for the task. So as I mentioned that as the LLMs are trained on a large amount of data and they have seen a large number of tasks during training, now when you want to apply this for a new task, it is quite easy. So you only have to provide few examples of the new task, and then it can simply start solving the new task. So this the process of giving instruction to the LLM is called the prompting. Okay, so the process of giving instruction in the natural language to a LLM is called the prompting. So there are different types of prompts. Like we can have a very zero shot prompting, where we can simply ask the LLM to solve a particular task without giving any example. Or we can also have few shot prompting, where we can give an instruction to LLM and we can also cite some examples. So this is called the few shot prompting. Or we can also have a chain of thought prompting, where we can ask the LLM to solve a particular task, and also we can give a step by step instruction. So there are different types of prompts, like zero shot prompting, few shot prompting, and also chain of thought prompting. So people, researchers are working on the prompt engineering. So the prompt engineering is a technique used in NLP to improve the performance of language models. It involves designing and refining prompts or input sequences that guide the model to produce more accurate and relevant outputs. So basically, you know that in which way we want to give prompt to a LLM, whether we should give in zero shot way, or we should give in few short way, or in the chain of thought. There are different stages, like we can apply multi-stage prompting. So there are different ways of giving instruction to a large language model, and that is basically called the prompt engineering. So many researchers are working on studying the prompt engineering process. So what are the different efficient ways of giving instruction to a generative AI model or a large language model? And this is called the prompt engineering process. So you know there are various prompt engineering mechanisms available, and this is a hot research area nowadays. Now, let me show you, before going into the application domain of, this generative AI in the agriculture and the healthcare domain, I just would like to showcase you some of the popularly used generative AI tools, because nowadays generative AI is very much popularly used in our day-to-day activities. So just I would like to showcase you some of the useful tools of generative AI. So one possible, we are regularly using ChatGPT or the Gemini from Google, or the Claude from Anthropic, and open source models like Llama from Meta. And these models are often used for generating summary from text or for text generation. Okay, so Llama from Meta exhibit exceptional instruction following capabilities and are widely used for open-ended text generation and summarization kind of tasks. So like whenever we have to generate a new text, or whenever we have to generate a summary, so for this kind of task, these Gemini or the Claude or ChatGPT are very popularly used. Like here you can see, like suppose we are giving a prompt, write a 60-word essay on the impact of AI in social science, and the ChatGPT or the Gemini can give us a writing on a 60-word essay. It will give us exactly 60-word essay on the impact of AI in social science. Or we can also give a passage and then we can give the instruction, summarize the following text in less than 20 words. So this way, these models are very good in summarizing any agriculture. For example, you can also, agricultural texts are also often very lengthy. So if you want to generate a summary of the agricultural text or the healthcare text, there are some medical LLMs. Okay, so these medical LLMs are only trained on the healthcare data. Like we have the MedLama or MedLava, which are trained on the medical data. So which are used for generating the summaries of the healthcare data, or generating some text for the medical data. So for generating the summaries, or for generating some text in the healthcare data, we can use some medical LLMs. So then we can also upload a PDF to ChatGPT or the Claude or the Adobe AI Assistant, and then we can ask a question related to the PDF. So for example, we can upload the resume of the student, and then we can ask a question, can you tell me the some options for the ideal career for this person with proper justification. So the LLMs can analyze the PDF, and they can provide the proper career justifications for the student. Okay, so they can analyze the PDF and they can provide the career justifications. Then there are many tools which can which can help us in writing the code. Okay, so there are some product like Tableau or the Visually. These are some generative AI solutions which can analyze the data and can generate some Python based code. So there, the similar capabilities are also shown by the models like GPT-4o, Claude, etc. So here we can ask, suppose if you are asking them to analyze some data, so in order to analyze the data, they can also write some Python script. Okay, so Tableau from Salesforce and Visually from AI-powered data analysis are very popularly used such code where you can they can also generate some Python script to analyze the data. So, like for example, we have uploaded this a data set developed by our students only, and then we can ask some question related to a data set, like analyze the given data set, and it can write a Python script to analyze the given data set. Or we can ask a question, identify the most common words used in the question and the question summary, and it will write a Python script to analyze the data set, and it will find out the most common words used in the question and the question summary, and then it will generate this kind of word cloud. Now there are some tools like websites like Semantic Scholar, ConnectedPapers.ai, MirrorThing.ai. These are some tools where you can we can which can help us literature survey. So the Semantic Scholar, ConnectedPapers.ai or MirrorThing.ai, these websites can help us in searching in help. These websites can help in literature survey. So we can search for a particular topic here, and they will generate all the related papers in this site. So, for example, suppose in the connectedpapers.ai, we are searching with the topic stereo hate toward identifying stereotypical bias and target group hate speech detection. And now it will showcase us all the other papers which are related to this particular topic. And it will also showcase in the form of a graph. So like here you can see that there are some large graph, there are some small graph. So large graph indicates that the citations are more for the paper, smaller graphs indicate citations are less. This way they will form a connected graphs. And now we can either we can, depending on our need, we can select few nodes which are connected with the current paper, and that will help us in writing the literature survey. So tools like connected papers provide high quality visualization, which will aid in the literature survey. Now, there are some tools like GPT-4o from OpenAI, then Google Gemini and the Claude models, along with open source model like Lava, InstaBleep. They have made the images interactable. Okay, so here we can upload an image, and then we can ask a question related to the image. Okay, so these models can take image as an input, and then we can ask some questions related to the image. So such model find applications in various social sciences domain, like sociology for analyzing media content, history to know more about historical images. Yeah, Snehanshu, any question? Or we can take the question at the end. So these models have good knowledge in sociology, they have good knowledge in history, psychology, emotional analysis, and many more. This Gemini, Claude, Lava, InstaBleep, etc. So like here you can see an example like InstaBleep, we can give this kind of image and we can ask, introduce me this painting in detail. And it can introduce this painting. The painting depicts a young girl with a pearl earring, who also known as the girl with the pearl earring or the girl with a pearl earring. She is wearing a blue dress and has a pearl earring on her left ear. Her hair is pulled back into a bun and she is looking directly at the viewer. This painting is a famous work of art by Dutch painter Johannes Vermeer, created in 1665. It is considered one of the masterpieces and is widely recognized for its intricate details and realistic portrayal of the young girl's facial expression. So you can see it has knowledge about the art forms also. Now, mini GPT V2, we have asked about the historical image. Please describe this image as detailed as possible. So it has started describing the historical image. The image depicts a large cave with a group of people painted on the walls. The people are engaged in various activities such as hunting, gathering, and riding horses. There are several horses scattered throughout the scene, with some in the foreground and others in the background. In addition to the people and horses, there are several other animals depicted in the cave, including a lion, a tiger, and a rhinoceros. The cave is also adorned with various objects such as a bow and arrows, a spear, and a shield. Overall, the scene appears to be a vibrant and lively depiction of ancient life, showcasing the skills and activities of the people who lived in the cave. So, these models have very good understanding of the art forms, very good understanding of the history, and very good understanding of the common sense. So nowadays, people are working on the diffusion models where you can give a textual description as an input and you will be able to generate some images. Okay. So like we have daily 3 from the open AI, Flux and stable diffusion. So these models, they take the input, some textual descriptions, and then they started generating some images. So, for example, here we are giving a very historical description of a historical description, like imagine a bustling 19th century marketplace in a small European town. The scene is lively with cobblestone streets lined with wooden stalls selling fruits, vegetables, textiles, and handmade goods. Townsfolk dressed in period clothing engage in conversations, haggling over prices. A horse-drawn carriage passes through the market, and in the background, you can see the spire of a Gothic church rising above the quaint thatched roof houses. The atmosphere is vibrant, capturing the essence of daily life in historical France. So it will, if you will give this description to Delhi 3, it will generate some images. You can see it will generate some historical images basically. So, yeah, so these are some useful tools of generative AI. And now I will showcase you how this basically, basically how these tools can help us in solving some task of healthcare and as well as in the agriculture. Okay, this was just an introduction, and now I will showcase you some of our research activities where we have used these tools for solving some task of healthcare and the agriculture. So let me start with a very recent work in the healthcare domain, where we have tried to solve a task called the multimodal question summarization in the healthcare. So what we have done is that nowadays, suppose you are suffering from some medical disorder, or there is a medical problem, or we are suffering from some symptoms. So we are going to a doctor, but before consulting a doctor or after consulting a doctor, in order to take a second opinion, we also used to write about our problem in a medical blog or in some medical forums. So there are many medical blogs and medical forums are available where we used to write about our medical concern. And many doctors are associated with these medical forums or the medical blogs, and they used to read these patients' queries, and they used to give some good suggestions regarding the questions raised by the patients. So now when the patient is writing the question, patient is writing in a very detailed manner. So now maybe the doctors do not have time to go through such a long query. So basically we need to get a summary of those medical questions. So this is basically the task, multimodal question summarization in healthcare. So we need to summarize the multimodal medical questions. Okay. So when we started working in this particular direction, there was no multimodal dataset available. So what happens is that suppose I am suffering from some symptoms, but I do not know the actual medical term which describes that symptom. So when I am writing about my medical condition, maybe I am not able to express myself because I do not know the medical terminology. So, but I can simply upload the image of the symptom and then I can describe my situation. So that way the image modality can give the much freedom to the user to write the medical condition in a better way. So that is the advantage of having the image modality in writing the medical questions. So we proposed a new task, multimodal medical question summarization, and then we proposed a new data set also. So the data set is having 3015 medical questions and the corresponding summaries. And initially there is a medical question summarization data set, but this data set was not having any images associated with it. So we worked in association with a doctor. He is from the Indira Gandhi Institute of Medical Sciences, Patna, and with his help, we annotated this dataset with the images. We collected some images from the online sources, and wherever possible, we replaced the symptom name with the image, and we made the dataset multimodal. And then we proposed a LLM and the visual language model based approach, a pipeline based approach. We have not done any training because these LLM large language models or the visual language models are already trained on a huge number of data. So we only used a pipeline based approach to solve this particular task. So this is our dataset. Healthcare Magic dataset was an existing dataset for medical question summarization field. So this dataset is having 3015 clinical question summary pairs. So what we did is that we identified that in some of the questions, for some of the questions, we can insert the image. Okay. So there are 587 unique images, and we can replace the question with we can insert the image in the question. So with the help of a doctor, we identified these 587 images, and the images are broadly categorized into 4 categories: ENT, eye, limb, and the skin. And the images and the final summary we modified accordingly, because now the image is also a part of the question and also part of the summary. And now we modified the images and the final summary, and those are also verified by the medical experts. So this is my data set, multimodal medical question summarization data set. So we have the images are categorized into 4 parts: ENT, eye, limb, and the skin. Under ENT, the main symptoms are lip swelling, mouth ulcer, swollen tonsil. Under eye, we have the swollen eye inflammation, itchy eyelid, eye redness. Under limb, we have the edema, hand palms, foot swelling, neck swelling, knee swelling. Under skin, we have the skin rash, cyanosis, dry scalp, skin growth, skin irritation, skin dryness, etc. And these numbers indicate number of images per symptom. So first of all, as I mentioned, this is a pipeline-based architecture. So what we have done is that we have not used any training procedure, because we do not have a huge amount of data. So training was not possible. So we simply used a pipeline-based architecture. So we use the pre-trained versions of the claim LLMs and the VLMs to solve this particular task, multimodal medical summarization task. So first of all, Clip is a visual language model. So we pass the image through Clip, and then the Clip was asked to identify the medical disorder which is mentioned in the image. So the image is given to the Clip, and the Clip was asked the question which medical disorder is present in the image. Describe the image in the disease in a single sentence, stating all the necessary details. And the Clip was identifying 3 medical disorders. Now there is a LLM, large language model. The large language model is given the input, the 3 medical disorders which are identified by Clip, and also the context. So, and then the LLM is given the prompt. You are an experienced medical practitioner given a query of a patient and 3 probable diseases. Tell me which of the given disease is the patient actually suffering from. So the original query of the patient is given, and the probable disease. So top 3 probable diseases are given. Extract the symptoms from the query and match them with the given diseases to find out the most optimal answer. Give only the disease name from the probable diseases as the answer. Do not give anything else or any explanation. So LLM is given the 3 most probable items. and also the original question, and the LLM is asked to select finally the only one disease name mentioned in the image. So it has been shown that if you will ask directly the clip, the most important disorder, then the accuracy is only 84%. But if you will follow this two-stage approach, that a clip is giving us the three highest possible disorders, and then there is a LLM which will prune the set, which will finally say select only one probable disorder, then the accuracy improves to 87%. Now there is a context generation module. So given the medical disorder identified from the image, we are passing this information to a LLM. So the input is the identified medical disorder and the output is the corresponding output. And we are using the LLM GPT 3.5 and we are asking two questions. So what are the symptoms of the medical condition, and what tests and procedures need to be done for the medical condition. So we're asking some additional questions to the LLM GPT 3.5 regarding the medical disorder identified from the image. Okay, we want to extract some more information about the medical disorder, like what are the symptoms of the medical condition and what tests and procedures need to be done for the medical condition. So that way we are extracting some additional information, and this is which is called the context. Now there is a context filtration module. So maybe all the sentences in the context are not important. So basically we need to see the similarity of the sentences in the context with the image. So if the few of the sentences in the context are not similar with the image, then those sentences are discarded. So this is the context filtration module, which removes out of context image knowledge generated by the last module. So this module simply calculates the similarity between the context sentences in the context and the image. And if the similarity is greater than some threshold, then the sentences are discarded. Okay. So this module is called the image bind module. So we are considering all the sentences in the context, and we are calculating the similarity between the sentence and the image. And if the similarity is greater than some threshold, then that sentence is basically discarded because that sentence is not related to the image. So this way we are discarding few sentences from the context, and we are keeping only those sentences which are highly similar with the image. So this is the overall pipeline. So first we are using the clip followed by LLM to identify the most important disorder present in the image. Then there is a context filtration module, context generation module. So one LLM is asked to generate some additional context from the image. So like what are the symptoms for the medical disorder, discuss it in a short paragraph, what tests and procedures to be done for the medical disorder. This way we are generating some additional context. So then there is a context filtration module. We are checking the similarity of the context with the image. If some sentences in the context are not similar to the image, then those are discarded. Now there is a final summary generation module. This is also a LLM. So this LLM is given the prompt, write a very short and concise one-line summary of the following dialogue as a question in a healthcare forum, incorporating the relevant medical symptoms in the additional context given below. So we are giving the user query, we are giving the additional context extracted from the medical disorder from of the image, and then we are asking it to generate a summary. And we've added various LLMs, and this LLM is generating the final output summary. So there are various LLMs, like we experimented with Llama 2, Red Pajama, Vicuna, Plant T5, GPT 3.5, etc. So you can see we have also done an ablation study, like what is happening with different modules. So like Clip Central is giving us the rules.
Sorry to interrupt. Okay, no
Yeah.
problem. Yeah, now slide is visible. Yeah. Okay.
Okay.
Okay,
So
ma'am.
Clip
Continue, please.
Central is giving us the rural score value of 40.9%. You can see that. And then the second base value is given by the Vicuna. Vicuna is giving 33%. So this rural basically measures the string overlap. Like you know the actual summary, and your model is generating the a summary. So how many consecutive words are matching? Okay, so that is the rules measured. So like in your actual summary, there are some words, and your model is also generating some words. So how many words are consecutively matching? So that is the rules value. Similarly, blue scores also you can calculate, and the bar score is the semantic similarity. So these are some values that we can calculate. And we have also done the human evaluation. So basically, as this is the healthcare domain, this is a very sensitive domain. So basically, what happens is that maybe when the user has specified the query, some medical disorders are mentioned in the user specified query. And now when we are generating the summary, some disorders are basically are not mentioned. Some omitted, the disorders are omitted. So we have to maintain, we have to calculate the fraction. So how many disorders are retained in the generated summary. So that ratio is basically called the MMFCM score. So we proposed a new metric that how many disorders are originally there in the in the question or in the original question, and how many of them are written in the generated summary. So that percentage is basically called the MMFCM score. So what we have done is that randomly we have selected the 100 summaries, and those 100 summaries are given to the human for the human evaluation. So doctors and his team have manually checked the quality of the the generated summaries, and we have checked with respect to the clinical evaluation score, factual recall, omission rate, etc. And you know that they have given this course, and they have checked that whether the produced summaries contain the original disorders or not. And these are the results. So results indicate that yes, in general the generated summaries are quite good compared to the original gold standard summary. So in future, obviously, this work was done in the English language. So in future, we want to work on more Indian languages, because Indian people, when they are writing in the forum or in the medical blogs, they do not write in English. So they are mostly writing in the code mix language, or they are writing in their native languages like Hindi or Bengali or some other native languages. So this work is now only done in English, but we want to extend this work in Indian languages. And moreover, only now broadly four symptoms are used: ENT, these four symptoms: ENT, eye, limb, and the skin. So we want to extend this for other symptoms, and and also more complexities, like currently we have only used the image and the text. So we need to introduce some more complex modalities like video. Sometimes maybe we can also upload a video of the symptom. So more complex modalities also we need to consider. So in our next work, what we have done is that we have converted this data set, which was in English, into code mixed Hindi English, because we people are multilingual, and we Indians speak in multiple languages. So whenever we are talking or writing in the social media or writing in the blogs, we do not write in pure English or pure Hindi. We switch between languages, and this is called the code mix or the code switching. So you know that how to convert. So basically, we need to first develop a data set of multimodal medical question summarization in code mix language, and then we need to propose a model which can deal with this code mix language. So that was our task, that we proposed a data set for multimodal medical question summarization, and we also proposed a new model called the MedSum, again, which is harnessing the power of vision encoder and the large language model to generate the final summary. So again, it was not possible to manually translate the English data into code mixed language, because it was very much time consuming, and also very human, manually it was not possible to done. So basically, we again took the help of the chat GPT. So we asked, GPT 3.5 to, and we have given this prompt that you are a linguistic expert whose task it is to convert the English passage into corresponding English code mix to one. And then we have given some examples. It was done in a few shot setting. So we have given some English examples and the corresponding few shot code mix examples. And then we have given this prompt that took ChatGPT 3.5, and we asked ChatGPT 3.5 to convert the entire health care magic dataset into code mix Hindi English. And in the code mixing, after the code mixing, most of the medical terms are kept in English, and the other terms are kept in Hindi depending on the context. Okay, so most of the medical terms are translated into are kept in English only, but the other terms are translated into Hindi depending on the context. So the code mixing ratio was kept as 30.5. So two-shot prompting that is used for the machine translation purpose. So you can see one example of this data set. So basically, you can see that suppose our English text is hi and thank you for your time. My 16-year-old daughter has formed some lumps or growths under her skin on her lower legs. They just appeared 3 to 4 weeks ago, starting with one lump on her right calf. She now has three lumps right calf, one large lump on right foot. Doctor, you can give a look at patient, some issue in my legs below and two new lumps on her left calf. Ultrasound was inconclusive and they have scheduled a surgical biopsy for 10/8. Lumps continue to get larger each day. I am just seeking a possible explanation or explanations to ease her mind. Thank you again. So this was the original English version. And when we are translating like this. Hi and thank you for your time. मेरी 16 साल की बेटी के लोअर लेग्स के नीचे उनके स्किन के नीचे कुछ गंध या वृद्धियां बन गई है. इनकी शुरुआत 3 से 4 हफ्ते पहले हुई. स्टार्टिंग विथ वन लैम्प राइट कल पर. अब उसे 3 गंध राइट कल पर, वन लार्ज लैम्प राइट फुट पर और 2 नए गंध लेफ्ट कल पर है. अल्ट्रासाउंड इंकॉन्क्लूसिव था और 10/8 को उन्होंने सर्जिकल बायोप्सी का शेड्यूल बना दिया है. गंध रोज बढ़ती जा रही है. मैं सिर्फ इसकी मानसिक शांति के लिए एक संभव व्याख्या या व्याख्याओं की तलाश कर रहा हूँ. फिर से धन्यवाद. Okay, so you can see that most of the medical terms are not translated, and other terms are translated into Hindi based on the context. So that code mix ratio is kept as 30.5. So target summary is always in English because we assume that the target summary will be read by the doctors, because the patients are writing their queries in code mix language, but finally the summary will be read by the doctors. So like, what are the possible explanations for the sudden appearance and continuous growth of lumps on a 16-year-old's legs? The images here shows a medical condition related to foot swelling. The foot is swollen with some redness. So these are the samples of the multimodal medical question summarization data set. So you know that then we proposed, we have initially tried using our previous pipeline based architecture only. So that VLM like CLIP and the LLM based architecture, but that architecture was not working fine for the code mix data. Somehow the CLIP the various LLMs, they were not able to understand the code mix data. So there was a necessity of fine tuning the LLMs. Okay. So CLIP Central like pipeline architecture was not working for the English data. So there was a need of end-to-end fine tuning. So we combined the visual encoder with the LLMs, and then we have done the parameter efficient fine tuning using the QLoad adapter. So this is our proposed architecture. So we have extracted some image-based features from the visual language VIT embedding, and we have also extracted some textual features from the LLM embedding, and then we have projected them in the same space, and we have concatenated the image and the text embedding, and then the few layers of the LLMs are are basically trained using the QLoRa adapter. Okay, and finally, QLoRa is a basically a process of training few layers of the LLMs, and finally, the summary is being generated in English. So, these are few results. So, you can see that we have the results with only text input, and also we have the results with text plus image. Okay, so MedSum is the text plus image, and unimodal means the only textual. So these are the results. So basically, we can see that with basically Bhikkhu now we are getting 37%. With the player Lama 2 we are getting 38.41% result score, and some BART score and Meteor score as well. And these are some again human evaluations. So we have selected 100 random summaries, and those summaries are given to the users. And users have doctors have basically rated whether in the summary there is any hallucinations, or the summaries have in the suppose in the original question there was some medical conditions mentioned, but now in the summary those medical conditions are omitted. So what is the percentage of that? So that way, some scores are given assigned by the doctors to the summaries, and we have taken the average values over the 100 samples. So these are the values of the human evaluation. So you can see these are some results, and the mostly that Mistral 7B, there is no hallucination in the output. So there is but red lines show some hallucinations. So Lama 2, Vicuna 7B, there are some hallucinations for the Mistral 7B. There is no hallucinations in the output. So again, in future work, we want to incorporate the severity information. So, like from the image, we can also extract the severity of the symptom. Or from the image, we can easily extract this information, and we want to incorporate the severity information in the generated out in the final generated summary. And as I mentioned, that we have till now used the image and the text modality, but we also want to use the speech and the videos in the generated output, and extending the dataset to cover more medical conditions. So till now we have used only 4 conditions: ENT, limb, eye, and so basically the 4 conditions we have used as I mentioned earlier: ENT, limb, eye, and the skin. But in future we would like to use some more medical conditions. So yeah, so these are our 2 works on multimodal medical concern summarization. So in the healthcare domain, and I have shown you how LLMs and VLMs without fine tuning can be used for solving some healthcare related tasks. Now I will showcase you how LLMs and VLMs can also be used in the healthcare in the agriculture domain. So let me show you that this is our work called the EcoSales Assistant towards building a multimodal plan care dialogue assistant. So basically nowadays we are keeping many in-house plans in our home. That, and when we are keeping many in-house plans, we have many queries related to the in-house plans. And we want to ask those queries to the LLMs, because we assume that LLMs know everything, so that's why we want to ask those questions to the LLMs. But mostly the LLMs are general purpose, so they do not have specific knowledge about the plantation plants. Okay, so if we will ask the Chat GPT or any other LLM regarding some plants, they will not be able to answer those questions. So can we develop a specific LLM based chatbot which has some knowledge regarding the plants? So with this aim, we propose a data set where, as if 2 people are discussing about some plantational related queries. And with this data set, we basically train a LLM so that LLM can provide answer to any of the plant related queries. Okay. So basically our initial observation shows that LLMs do not have good knowledge regarding the plants. So we really require to train them or fine tune them with the plant care related query or the plant care related knowledge. So that was the observation of this particular paper. So in order to assist online plant healthcare seekers through the intricacies of plant care. We aim to build plant care assistant. So you know that, but in order to fine tune the models, or the in order to fine tune the LLMs, we really need a data set. So there is a data set called a plantational, which is a multimodal, multi-turn plant care conversational data set. So as if two people are talking to each other, and this data set is having around 1000 K conversations. So this plantational data set is downloaded from the Reddit and the Housey websites, and where there are many users who are posting their concern, and the other users are commenting on the concern, and this way there is a thread of conversations. So we downloaded those conversations, and then we give it a dialogic form, okay, as if one question is asking a question and the other question is giving the answer to the question. So we made it a dialogic form, and this dataset is basically called the plantational dataset. And then on this dataset, this is a very small dataset. There are 1000 dialogues, and each dialogue is having 3 to 4 utterances. So there are 4000 or 5000 utterances. And with this dataset, we basically train our proposed, we basically fine tune our ecosys model. So we build the ecosys, a multimodal plan care assisting dialogue generation framework, incorporating adapter based modality infusion using a gated mechanism, and train on plantational dataset. So basically, there is a multimodal plant care assisting dialogue generation. So where is it is a LLM based agent only, and we can ask any question to this plant care dialogue generator, and it will be able to answer all those plant care related questions. And we investigate the efficacy of different LLMs and VLMs for plant care assistance. So this is our dataset creation part. So as I mentioned, the initially we tried using the pretend LLMs for solving the plantation related queries, but somehow the pretend LLMs were not performing good for the plantation related queries. So we understood the need of fine tuning the LLMs for solving the task of plantation related queries. Like if you want to ask specific question regarding the plantation, like in in-house plants and etc., how to take care of the in-house plant, or how to water the in-house plants, or suppose you will not be in home for few days, so how to take care of the in-house plants. So all these typical questions, if you want to ask the LLMs will not be able to answer them properly. So this means that you really need to train LLMs, fine tune LLMs with the in-house plan related knowledge. So we collected the data from the Housey and the Reddit, and you know that there the conversations are of this format, and again it is multimodal, because when the users are conversing with each other, they are not only conversing in text, but they are also uploading the images, okay, as a part of the conversation. Like user A is saying, hi, I have had this diphtheria pendens golden fuchsia plant for 2 days. So he or she is referring to this image. I put it in a clay pot and watered it 48 hours ago. Walked into my office this morning and it is wilting already. I had never had a plant this delicate before, apparently. Okay. Now the user B is giving the answer. If your plant's leaves are whittling, it may be due to one of the following reasons. Overwatering can lead to root rot. Underwatering can cause the plant. Lack of light is getting enough light. Too much light, conversely, too much light pest or diseases can cause the patients. To solve the issue, you should check the soil moisturizer level, providing shades if necessary. If pests or diseases are present, treat the plant with appropriate measures, insecticide or fungicide. So these are the comments or the responses from the user B. So you can see that user A is asking a question and the user B is then giving an answer. So now we are giving this a dialogic format. So we have collected this kind of data from the Housey or the Reddit, and then we are giving it a dialogic format as if two people are discussing on this plantation related issues using multi-turn dialogue. Like user is asking what would be the possible reasons for the whittling of the Dipia spanders plant. Agent is saying there are several possible reasons for whittling leaves in plants, which may include overwatering, lead to no root, underwatering, causing the plant to lose moisturizer, presence of pest or disease, like this. So user is again asking what steps can be taken to address the whittling issue of the plant. Check the moisturizer level of the soil and water the plant accordingly. If pests or diseases are present, treat the plant with appropriate measures such as using insecticide or fungicide. So this way we are collecting the data from the Reddit or the Housey, and we are converting this into a multi-turn conversation between the user and the agent. So finally, the dataset is having 963 dialogues. There are 4913 utterances. There are 12,953 distinct words. The average number of utterances are 5.1. Maximum number of utterances are 12. Minimum number of utterances are 2. And number of dialogues having images. All the dialogues are not having images. Their total number of dialogues are 963, but around 167 dialogues are not having images. So 796 dialogues are having images, and 197 dialogues are not, 167 dialogues are not having images. So now this is the proposed ecosys model. So you can see that initially, as I mentioned, we have tried using in the zero shot setting. So whether the proposed model is able to generate the answer without, without any training. But the LLMs do not have knowledge much regarding the internal plans. Okay, so they were not able to generate correct answers for the internal plans. So what we did is that we use a fine tuning based approach. So we have used VIT embedder, so generate the embedding from the image, and then that then we are getting the context and also the question what causes the damage the part 3. So the embedding is taken, and then there is a Vicuna. So Vicuna is a large language model, and that we have used the LoRa based adapter. So LoRa based adapter basically trains few layers of Vicuna. Okay, so LoRa based adapter basically trains few layers of the Vicuna with the dataset with the dataset obtained. So you obtain visual embedding from VIT and cube format, project it and concatenate it with a textual embedding. We insert LoRa modules inside Vicuna decoder and train it on the plantational dataset. So, like if our question is what causes the damage to the birth tree, and we show the image also. And now, suppose if the output is the damage to the birth tree is caused by a sapsucker, which is a type of woodpecker known to feed on sap from living trees like birches. So then that this is the way that first we will be giving the a feature vector from the image and also the feature vector from the question as an input to the Vicuna. Now the few layers of the Vicuna are already trained using the QLoRa adapter. Those are fine-tuned using the QLoRa adapter using the plantational data set. And finally, it will generate the output like this. So it will generate an answer to the question. This is the ecosys model. A and B represents the LoRa modules. We train LoRa and the linear projection layer from visual encoder to text decoder, while remaining model is frozen. So these are the results. So you can see there are various models: Plan, GeoNeo, GPT Neo, OPT, Vicuna, EcoSales. These are the various models. And you can see that our values are RU score value, Blue score values, BART F1 score values. So these are the various values, and we have shown results with different scores like zero shot, few shot, and the fine tuning. So with fine tuning, we are getting like Mostly with the Vicuna, we are getting 27.20. Okay. And so basically, you know that with blue, we are getting 6.49. And for BART, we are getting 61.13. So these are the results. So plan, we are getting BART score of 63. So we are getting these results. So, and also human evaluation is also done, like whether the responses are really fluid, responses are adequate, what is the fluency level of the responses, whether the responses have information content in it, whether the responses are contextually relevant, or whether the responses are image wise relevant or not. So these are the different scores. Plantify, GPT Neo, OPT, Vicuna courses. So these are the various results you can see. We have calculated the fluency, adequacy, informativeness, contextual relevance, and the image relevance. So we find that LLMs face challenges in delivering satisfactory responses to user queries pertaining to plantation. This underscores the necessity for LLMs to acquire more domain-specific knowledge about the plants. So basically, what we have to do is that we need to somehow, that so here it shows that somehow zero shot or the few shot setting were not working well. Like in general, all these LLMs like the plan or GPT or the OPT, Vicuna, Ecos, etc., they do not have knowledge about the plans. Okay, so we really need to fine tune the models. So we developed a new data set, and with this new data set, when we fine tune the models started generating good responses regarding the plant care related questions. So the results of the zero shot and few shot setting show that models do not have knowledge regarding the plant care plans. So we find that LLMs face challenges in delivering satisfactory responses to user queries pertaining to plantation. This underscores the necessity for LLMs to require more domain-specific knowledge about the plants. We find it essential to include semantic evaluation in addition to textual lexical evaluation. So basically, sometimes when we are this roux score and blue score are simply doing the string matching. So maybe string matching is not enough because LLMs are generating the answer in its own language. So maybe they are conveying the same information but its own language. So we should not only match the strings, but we should try to understand the semantic meaning, whether the generated response and the original response are semantically correct or semantically similar or not. So basically, these blue scores or the blue or the BART F1, these scores measure the semantic similarity between the generated response and the original response. So basically we find it essential to include semantic evaluation in addition to lexical evaluation, as we find that having lower blue score such as Vicuna achieves higher BART1 F1 score. So basically you can see that Vicuna is giving a very low blue score, which only 6.49, but it is giving a very high BART score. So this means that maybe it is answering the same answer, but in a different way. Okay. So if you are doing the string matching, it is not matching at all, but it is giving the same information in different words or in a different style. That's why we need to rely on some semantic similarity, not on the lexical similarity. So yeah, so this is a work on the agricultural domain where we have tried to use the LLMs and the VLMs for developing a data set fast. So there was no this kind of plantational data set where two agent and the bot, agent and the user, like there is a chatbot like Alexa or Siri, and the a chatbot and the user are discussing on the plantational related queries. So there was no such data set available, and so we proposed this dataset, plantational dataset collected from the edit and the housing. And this dataset is having around 4900 utterances. And then using this data set, we fine tune the vicuna. So vicuna is having few layers, we have fine tuned the few layers of the vicuna. So this is the one work that we have done in the agricultural domain. Now, moving forward, we have also developed some summarization modules for the clinical documents. Like suppose the doctors and patients are discussing, nowadays, you in the YouTube, you may find many doctor-patient conversations. Like there are many counseling videos available where patients and the doctors are discussing on a particular topic. So basically, this work is just to summarize the patient-doctor conversations. So suppose at the end of the conversations, patient want a summary. So doctors and patients have conversed on a particular topic. At the end of the conversation, from the patient basically wants a summary of the conversation. So how efficiently, and as I already mentioned, that when the patients and the doctors are conversing, maybe the patients are not aware of many medical terms. So they can simply upload the images of the medical symptoms or the medical terms. So doctors have to understand from the image what are the symptoms the patient is suffering from. And this way, this is also multimodal patient-doctor conversation. And from this multimodal patient-doctor conversation, we have to generate a multimodal summary. So in this particular work, we propose a new kind of summarization module, which is applicable for clinical document summarization. Okay, like here you can see that suppose this is a question. 11-year-old daughter diagnosed MRSA plus 13 days ago started having high fever 5 days ago, which we keep down with Advil cause. Also feeling unwell and severe fatigue. Notice bad breath and very with white spots all over them. Please, doctor, see the current condition below. Tonight goes to bed with fever and a bit of Advil. Later, she got bad sweets, cold body temperature 49.9, and was shaking so much. Bad to wake her was scaring me. Had to change her to dry PJs. Back to bed with again cold sweats. So this is the description of the question, and some images are also there. So now we want to generate a summary of this question. What would be the cause of high fever, swollen tonsils with white spots, severe fatigue, and cold sweats with low body temperature in an 11-year-old girl recently diagnosed with MRSA? So, how can effectively summarize a multimodal medical document while retaining key information from all included modalities? So we use three data sets. So obviously, this summarization is having importance because doctor-patient imbalance, urgent need for the healthcare automation. Doctors do not have time to go through such a lengthy question. So they need to see the summary. Telehealth growth, COVID-19 and ICT advances drive telehealth. Multimodal data, patients use both text and images for better clinical evaluation. So we proposed a new encoder-decoder based model where in the encoder side we proposed a new kind of attention, and also in the decoder side also we proposed a new kind of attention. So we introduced the ADSAM, a multimodal transformer model that uses contextual image fusion in the encoder and image cross attention in the decoder for better alignment of image and textual modality. Okay, so what we did is that we this is our proposed model. So in the encoder side, we did some modifications. Okay, in general, in the attention, people used to use some cross modal attention, like they are taking the queries from the question, and the keys and the values are only coming from the image. But we are saying that no, key and value will be a combination of image and text. Okay, so the query will always come from question, but the key and the value will be a combination of text and image. Okay, the importance of the text and image. So there is a parameter lambda. So the query and the key are a function of lambda. Lambda into image plus 1 minus lambda into text. So what will be the value of the lambda? That is a learnable parameter. So through the backpropagation and through the trading, we need to learn the value of the parameter lambda. Okay, so basically now this we need some modification on the contextual image fusion. So now here the attention is put on the question and the image, and that key and the value are a combination of the image and the text. Similarly, the decoder side also we put attention, and that in general people used to ignore the attention in the decoder side, but now we have also inserted the attention in the decoder side. So this is called the image cross attention. So in general, only in the encoder decoder model, when we are generating the summary, people used to put attention on the encoder side, but we have also put attention in the decoder side. So we use three data sets. One is already I have mentioned about the two data sets: multimodal question summarization data set in English, multimodal question summarization data set in code mix format, and then the multimodal clinical conversational summarization data set. So this multimodal question summarization data sets are having 3015 data points and covering 18 medical symptoms. And in the code mix data text is code mix Hindi English code mixed. And the multimodal clinical conversational summarization data set contains 1668 samples with coverage of 266 symptoms. And all data sets focus on multimodal question dialogue summarization in healthcare. So these are the results. You can see that we are having different ways of encoding the image. We are using ResNet or VGG or VIT for encoding the image modality. And these are the results. So we are having, you can see that 47.14% user score. And these are the results with the first data set, on the second data set, third data set. And these are the results with the on which layer we have to integrate the image and the text modalities. And these are the some quantity study, and basically we made some modifications in the encoder and the decoder side of the transformers. So we introduced a new way of attention mechanism, and that also we evaluated the models, and we proposed a new way of generating the summaries for the clinical documents and the clinical, mostly for the clinical documents it is important, because for the clinical documents we have to generate this, we have to put the emphasis on the image part. Yeah, so basically, I think I can stop now and I can take some questions. So these are the few studies that we are currently doing in our lab for generative AI and their applications in the healthcare and also in the agricultural domain. So through my talk, I just want to focus on how generative AI techniques can be used for solving the task of healthcare and also agriculture. So I hope you now got some idea that how LLMs and the VLMs can be used for the LLM, for the healthcare and the agriculture domain. So if you have any question, you may ask now.
Participants, if you are having any question, please directly ask. You have been unmuted.
Yeah, Anthony.
Yeah, ma'am, actually, the last model you mentioned about the multimodal summarization. So, ma'am, in that case, the patient can ask the model using some English question and some images, or it can be from any other languages also.
No, so currently the model, this multimodal like the last summarization model. The summarization model can handle the code mixed Hindi English and as well as the English data. And if you can change the encoder part, then it can handle any kind of languages.
Okay, okay. So,
Like you
encoder.
only have to change the encoder part, okay? Like
Okay.
if you want to encode the English, Bengali English code mix data, you only need to make some changes in the encoder part, and then the model will be capable of handling any kind of languages. Only some, otherwise the model is very generic and it can handle any language.
Okay. Ma'am, can we have the is there any source of that language data set? Is it available online?
Yeah, so you please visit my page, like I have mentioned in the first slide only. So you please visit my web page. So whatever resources we have developed, so those are available in my website. So okay, so there is this my website link is there. So www.iitp.ac.in /resources.html. So yeah, as a part of our research, we are developing many data sets. Okay, in some are also in the healthcare domain. So you can visit my website and you can download the resources from this web page.
Oh, thank you, ma'am.
Yeah, here I have posted.
Participants, if you are having any question, please feel free to ask.
So, ma'am, thank you very much. And if the participants have more queries, maybe not now, then they can obviously communicate with Dr. Sriparna Saha offline through email. So once again, on behalf of the organizing committee, I extend heartfelt thanks to you for having the time and delivering this wonderful session, where you have presented the data set as well as the model and the outputs, and what are the pros and cons, each and everything. And both you have covered both the research domains of AI in generative AI in healthcare and agriculture both. That are the focus area of this FDP. So with these words, thank you, ma'am,
Yeah,
and
yeah.
ye-
Thank you, Suparna. Thanks a lot, and thank you, Sohail, also for inviting me in this FDP.
Thank you, madam.
thank you
Yeah,
so much.
yeah,
Look forward for future endeavors as well. Yeah.
yeah. I'm leaving. Yeah, bye bye.
So, dear participants, there is only a few minutes gap to start with the session 2. And we will hear Dr. Arindam Pal in the next session. And this session will be from industry perspective, and he is a very senior person as the and very highly expertised in this particular domain of research. So please wait for a while, and we will start soon. Please be connected once the speaker is joining us. Immediately we will start session 2.
Speaker has already joined, madam.
Oh, I haven't noticed. Okay. So I welcome Dr. Arindam Pal. Can you hear me? Hello. Okay, so no issue. We will start at sharp at 3:30. Good afternoon. So, distinguished speaker of this session, Dr. Arindam Pal, has joined us. Welcome you, sir. Hello, can you hear me?
Thank you, Professor Suparna, for
No,
introduction.
yes, no. I will just give you a brief introduction. How are you?
Yeah, I am doing well. How are you?
Yeah, fine. With the brief introduction, the session will be over to you, sir. So, dear participants, we are about to start session 2. Dr. Arindam Pal is a director of data science and optimization at Optim, where he makes transportation companies more profitable and efficient through the use of optimization and AI. His research interests are in algorithms, artificial intelligence, data science, optimization, and machine learning. He has more than 17 years of industrial research experience in data science, machine learning, cybersecurity, and optimization, working for world-class companies like Microsoft, Yahoo, Novell, CSIRO, Cognizant, Optim, and TCS Research. He has published academic papers in reputed conferences and journals and was granted patents in various countries like India, USA, and Europe. He is a technical program member for several reputed conferences and technical reviewer for many renowned journals. He earned his PhD in Computer Science and Engineering, Computer Science from the Indian Institute of Technology, Delhi. He is a senior member of both ACM and IEEE. So, with this brief introduction, the session is over to you, sir.
Thank you, Professor Bishas and Professor Shaib also for inviting me and allowing me to present our work. So this is a joint work with many of my academic collaborators, and I'll of course mention all of their names. So let me start by sharing my slides, and please let me know whether you can. Okay, in just a minute. Let me know whether you can see my slides.
Yes.
Can you see it?
Not yet, sir.
Oh, okay. I think now it has come, right?
Yes, sir. Yes, sir. It is showing now.
Okay. So shall I start?
Yes, sir. Please.
Okay. Yeah, so thanks again to the organizers for organizing such a wonderful event about the faculty development program, because it's really useful for the new faculties to learn many of the current state of the arts in many areas like artificial intelligence or cyber security or Internet of Things. And thanks again for allowing me to present my work here. So today I will talk about task allocation using a team of robots. So this is a joint work with many of my collaborators, and I'll mention, of course, acknowledge them as we proceed. And so I always like to have like that my participants ask questions during the talk. So please feel free to ask questions, and preferably I don't know whether you can because I will not be always be able to look at the chat, because I'll be looking at my presentation. So so either you can talk it, or maybe one of the moderators can let me know. I mean, maybe by reading the questions, okay? Because I will not be monitoring the chat window, okay? So
Yes,
maybe one of the, if they cannot ask directly questions, if they are muted, so please, one of the moderators read me the question, and you can interrupt me anytime if you want. So I'd like to ask the question there rather than going at the end. Okay. So I always like to be this session to be very interactive, and I hope you like this session. I mean, it will be very interactive. So before starting, I would like to acknowledge the traditional owners of this land. In this case, I am sitting here at in Sydney, the Gadigal people of the Eora Nation, and their elders, past, present, and emerging. So I would like to start with the quote of the day. So for me, of course, the day is almost finished. It is 9 o'clock, but for you, at least, it is in afternoon. So the quest for optimality is the quest for truth. And you will see in many of the situations in real life, because always life is about making decisions, and you want to always take optimal or near optimal decision, right? So nobody wants to take suboptimal decision. And as you will find in many cases, finding a solution or making a decision is not very difficult, but making a optimal solution, making an optimal decision or finding an optimal solution can be very hard. And I mean, that is what the quest we always have, both in life as well as in our work, and that is exactly the quest for truth. You will see also some of these things that this is very hard in most of the real world situation, and we'll discuss a lot of the real world problem and discuss some of their mathematical equivalent by modeling them mathematically. So a little bit about me, because I am giving the talk, you should know about me a little bit. So I basically work at the intersections of algorithms, artificial intelligence, machine learning, robotics, and optimization. I enjoy teaching, of course, doing research. I mean, that is my, of course, first passion. I like to give talks and mentoring students, and particularly PhD students. I put a lot of emphasis on the pedagogical aspects of computer science and mathematics. So that's why I like to emphasize on the conceptual aspects. I don't like to work on problems where it is like a black box, or where I'm not giving a structural understanding or insights about a problem. So I don't want to understand everything inside a problem or the solutions. So I try to also find subtle connections between problems for different areas. So this has helped me a lot in my life, both in mathematical problems and computer science problems. So I try to use ideas from one area to solve problems in another area. So you should also always go either read papers or books, and also go to talks which are not necessarily in your area, but you may suddenly get some inspiration or some good ideas from one problem, and then you can probably apply it to another problem, or the problem that you are working. It's not easy. I'm not saying it is not easy. That's what separates maybe the average people from the good or the great people. But as you do it more and more, you will also get better, and you will be able to do that thing. That makes research so enjoyable. And I always try to come up with simple, beautiful, and elegant solutions for complex research problems. So getting a complex solution or ugly solution, probably many people can do, but getting a simple and beautiful solution for complex research problem, that's what separates the great researchers from the mediocre researchers. So you should always strive for simple, always strive for this, try to solve a problem from first principles. If you cannot do that, of course, you go to most sophisticated tools and most sophisticated tools and machineries to do that. But don't start with the very complex machinery. Start with simple and first principle solutions, what you have been taught in the classes or in the book or by the teacher. So I always do that. I mean, first start with the simple things. If I cannot find, then I go for complex problem as needed. I don't tend to like to introduce unnecessary complexities which are not needed. So okay, so now I'll start with today's agenda. So first, I'll describe the multi-robot task allocation problem. Then, of course, I'll define this precisely. Then I'll talk about its applications in the real world. And there are many applications in the real world. And you will see that many of these applications, robot does not literally always mean robot. Robot can mean different things, like it can be a drone, it can be a vehicle, it can be a person, it can be some other kind of entity. So robot or agent is a generic thing which can mean many different things in many different real world contexts. Okay, so don't literally think that it is just a robot. And then I'll go through a very important multi-robot task allocation taxonomy, and which will put this into a nice perspective and give you the principled approach to the whole area. I'll also discuss some of the problems which are studied both in mathematics and computer science, which are closely related to MRTA. Because whenever you, suppose you are given a new problem, so you can only understand this problem if you can find some connection with existing problems that you know. So that's the only way we learn. So if somebody tells you this is a cat, so to try to deciding that it is a cat, you try to find it. I have seen one or two cats. Is it similar to a cat, or is it similar to a dog, or is it similar to a human, right? So that's how we decide based on similarity. So in mathematical problems also, you have to know, suppose I know that this problem is almost similar to this problem, and then there is only these differences, and then maybe how I can use the similarity of these two problems to find out a solution for this unknown problem. where I know something about it, and these are very useful for learning and for your own learning also, and for solving problems. Then I will describe a very general mathematical formulation that we have come up with for this multi-robot task allocation problem, and illustrate with this with some nice examples. Then I will describe an algorithm for one particular. So MRT is a very general problem, and it is quite complex. So it is very difficult to solve this problem in its full generality. So we will show for one particular specific instance, which are very useful on some particular settings. So we developed a very nice and intuitive algorithms, and I'll go through the details of these algorithms. Then I'll describe some of the experiments and results related to that particular algorithm, and show how our algorithms perform better than the state-of-the-art algorithms. And I'll conclude this talk and give some direction for future research. Also, again, if you have any questions during the talk, please feel free to ask me. I'll be happy to answer during the talk. Don't wait till the end, and maybe one of the moderators can read it out for me, because I'm looking at the slides. I cannot monitor both the chat window as well as the slide. Okay. So let us start what it means to collaborate in a multi-robot system. Now, we all do collaboration, right? As humans, we do collaboration. For example, I do research and academics. I am very fond of collaborating with typically either professors or research scientists, or their students, either PhD students, or maybe by bachelor's or master's students. So, and that really helps me to develop my abilities even further. I get to learn about more new problems, interesting solution approaches. So, and that is not only true for humans. Interestingly, that is also true for other kind of agents. For example, robots. So, what one robot can do, if a group of robots or a team of robots, they join hands, not literally because their hands may be different from our hands, but if they collaborate, they can achieve much more than what an individual robot can achieve. So here it is like 1 + 1 is more than 2, you can say. So here is one scenario. So consider an industrial facility where you have a team of robots that have been deployed to provide some kind of services and perform some different tasks. So there can be many different tasks that are possible. So some of them are handling an object, transportation of something from one place to another, pick up something from one place and deliver that thing to other place, and there are many different more kind of these kind of things. Okay. Now the interesting thing is that to note is that not all robots have similar capabilities. So the way, if you have 10 humans, their capabilities can be very different. So they can be, one can be their upper body strength can be very high. They can pick up maybe 50 kilo weight. Another person can weight only 5 kilo weight. Or one person can run very fast. Another person may not be able to run so fast. Some people may not even be able to walk properly because they have some disabilities or something, right? So they have different kind of capabilities. So similarly, robots also have different kind of actuation, manipulation, and perception capabilities, because they are made by different kind of companies with different budgets and for different purposes. So, so they are what is known as heterogeneous robots, contrast to the called what is a homogeneous robots, where all the robots in a group has similar kind of capabilities. Okay. Now the challenge is that although these robots can have different kind of capabilities, so they must be still coordinated, because the tasks they are given to these multi-robot systems, they are very complex. So the robots have to collaborate among each other, and they have to be coordinated to perform the complex tasks. So, and also not only they have to collaborate with each other, but they also have to collaborate with human operators. So so now the thing is that this is a very non-trivial task. I mean, to collaborate with other robots as well as a human operator. So we have to do it in a very effective and efficient manner to supervise all the robots and coordinate them for a system with heterogeneous system. That means there are different robots with different capability. So this is a lot of work. I mean, and it's a complex research problem. So it needs a decentralized framework that can consist of many things, but among them are high-level task planning, low-level motion planning and control, and robust real-time sensing of the dynamic environment of the robots. Now, a multi-robot system is a very complex kind of systems, and we cannot address everything in one talk or even one paper or two paper, right? So this is a different aspect. So in this talk, my focus is on the first aspect is the high-level task planning between the between all the robots. Okay, so they will be allocated different tasks and how they can do in an optimal manner, and if that is not possible, in a near optimal manner. So that is the goal of this talk and my research. Okay, so there are other many other researches that address the other problems in this multi-robot system. So, but that's a talk for maybe another day. Now here is an illustration. I want to show illustrate a multi-robot system. So for example, in this system, suppose a new task arrives. So it may be, for example, picking of an object, right? And so, and suppose there is some kind of a change in the environment, and as a result of that, what happened was, there was the robot was doing something, and there was some kind of failure. Maybe the battery went low, or maybe it was trying to move something and it tripped over, and then it could not get itself up without an help from either another robot or the human operator. So so then in that case, what you have to do if something happens in the and it was not unexpected, it was not going according to the plan, so they have to adopt in response to those kind of changing environment, and for that you require some level of fault tolerance built into the system. Okay, so that even if suppose one robot goes down, so other robots can take up its position. And of course, if you have, say, suppose 10 robots, one robot fell, with 9 robots you cannot be as good or as efficient as 10 robots, but at least with a degradation of service quality you should be still able to perform that. Maybe it will require more time to do that, but that's okay, at least you are able to provide all the services. But sometimes it may not be possible. For example, if that robot has certain capability which almost no other robots have that, so that perform task cannot be performed by the other robot. So it's a complex scenario. So okay, now let me try to define formally the multi-robot task allocation problem. So basically a task allocation, when you talk about the task allocation in a multi-robot system, so this is the problem of determining, so you have been, so in this system, there is a set of tasks that have been given. Okay, say maybe there are 100 tasks and there are maybe 7 robots. And then you have to find out which robots should execute which task in order to achieve the overall system's goals. And typically you want to do this in an optimal fashion. And of course, these are kind of a broad statements, but I'll go through some of the specific instances to make them concrete. But this is at a high level, this is the goal. So you have to do a plan of the thing, you have to schedule this thing, and then you have to do ordering of them, and then you have to execute them. So the most important thing here is that you want to ensure coordinated team behavior. Okay, so the robots should work together to achieve the goal of the system. So they are not competitors here, they are collaborators. So by collaborating with this team will achieve something which a complex job it will perform, which would not have been possible if one individually robots should have worked alone. Okay, now this is a very important aspect of many multi-robot systems, and so it is these features and complexity of this MRTA are determined by the requirements of the particular domain, and we'll see going forward what exactly I'll quantify or qualify those things. And note that here we are interested in explicit cooperation. That means the robots are intentionally cooperating, and not implicit. And here tasks are explicitly assigned to a team of robots. Okay, so it's not that the so there is a planner which actually is an algorithm. I mean, maybe earlier days humans used to do that, but there is an algorithm in the planner. In this is an algorithm who will look at the overall systems perspective and look at the task, for example, the duration or their weight or so on, and then try to assign it to the robots in such a way such that this job is done in a more efficient manner and hopefully in an optimal manner. But you will see, as soon you will see that doing all these things are very hard. I mean, to achieve efficiency as well as optimality uh, and do it in a low cost way. I mean, this is really hard. I mean, and these are there are fundamental mathematical hardness involved. It's not nothing and not as much to do with the system aspects as such. So it is, these problems are inherently hard. Uh, okay. So if you have any questions, please feel free to ask me. Uh, so here is a simple example of a MRT in action. So this is the robotic task sequencing problem where you have some kind of a robotic hand which are doing that thing. So for example, there may be multiple, so IK is inverse kinematics. So multiple IK is there. So maybe two of them, I just for simplicity gave the two examples. So there can be, it may be required that the robots, when they are moving these things, so there are obstacles around, and then they have to avoid those obstacles. Obstacles. Then there may be different kind of base layouts where one robot is, or in this case the IK, so which is basically let me interchangeably call them IK and robot. The robots are positioned into different positions, and there may be some kind of partial ordering involved. For example, one task can only be performed only when one or more tasks has been performed, right? So for example, in this case, I have given an example for the triangle task. Triangles are just for, I'm just categorize them. There is nothing inherently specific about triangle or square. So triangle task has to always come after delta task. So for example, in this case, you can see that 1, 2, 3. So triangle coming out delta, or maybe 1, 2, the 1, 2, 3. So these two are legal things. A circle task can do in any way. So that you see that there is a partial ordering there. So triangle task has to always come from the after the square task to be legal or valid ordering. So then you can do some kind of task specification of this thing, how in which way they will perform, and the IK will go move from one place to another. And then there is some objective function, because that is ultimately the system's goal, right? Maybe you want to minimize the total amount of Cartesian distance or the cycle times and so on. It varies exactly depending on the applications and the context. So the domain specific, it is domain specific, and the operator of the system, he or she decides so what is the profitable one? Maybe he or she wants to minimize the total amount of distance and consequently the total amount of petrol so you want to minimize that, right? Or maybe he wants to minimize the amount of battery spent and so on. Okay. So here are some real life applications. First let me tell you that when I did this work, it was not in the exactly in the domain of either healthcare or agriculture. It was done in the domain of a warehouse management in a very similar setting like Amazon. In fact, we got this problem when I started when I was working as a research scientist in
Sorry to interrupt. Just
yeah.
to know, would you like to take questions after the session or in between
No, I would love to as a
question?
question in between. Yeah, can you please
So
tell me?
there is one question. There is one question from Shagorika madam. Could
Okay.
you please ask the question, or she has typed in the chat box also?
Yeah,
Team, could
you
you
can
please
ask question. That will be very good. I mean, or what?
unmute Shagorika madam who has raised hand. Hello.
Participant
Hello.
having question, please ask. You have been
Yeah.
unmuted.
Okay, till Shagorika madam is asking, I see another in the chat. I'm answering that, and then she can ask the question. Okay. So there is a question from Devshekar Laha. He is asking, in this group of robots, are you talking about autonomous robots only, or few of them are autonomous and few are operated by human? So okay, so in general, I mean, we want complete autonomous systems, right? So I mean, most of the, so for example, the scenario I have in mind, robots operating in a warehouse. So that is exactly all the robots are autonomous. So these are typically the like the things that they do, like in this big companies like Amazon, Flipkart, or eBay. They maintain large warehouses. So okay, so that is the thing. But it can be possible that some of them are autonomous and some of them are operated by humans also. But we want to actually obviously do it for fully autonomous systems. Okay, and, yeah. Now, Ms. Sagorika, can you please ask Professor Sagorika?
No question is chat box. I'm
I mean, can she ask? I mean, she's, I think, muted, so I don't know. She can unmute herself,
But
or
she
yeah.
and ask. But I guess there could be an accidental raise hand issue.
No,
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 maybe
she typed
she asked it.
something. A group of robots, something kind of thing. She typed.
She's
Uh,
not. Not she. That was asked by Mr. Dev Shekhar Laha.
oh, okay, okay, okay. No problem. Okay, please carry
Sir,
on. Then I just want to know that would you take the question in between or at the end?
Yeah, that's what I said also. Yeah, I want to take it in between. Just so
Okay,
please let me
okay,
know, okay? Whenever, because I am looking
okay.
at the thing, I'm not monitoring the chat. One of you please monitor,
Yes, yes.
and you can just
We are looking into it. Yeah.
yeah.
So no
We just
problem.
interrupt me. I will be happy to ask questions. It's much better
Okay,
to do it during. Okay. So
okay.
anyway,
Thank you.
yeah. So the original motivation for this was when I was working in TCS as TCS research in Kolkata as a research scientist. So we got one of our, so we are also supposed to work with the business group and help them, because we are the research group, and we are supposed, as a scientist, we should help them solve complex technical problems. So one of these such requests came from I think it came from Woolworths in Australia. I mean, at that time, I did not even never heard about Woolworths. Now I know in Australia, Woolworths is a big supermarket. So they wanted to have this thing that they have big warehouses and they have depots, and they want to pick up things like, for example, in the shelves and bring it to the depot. So how can they do it? So they were actually experimenting. Earlier it was done by humans. They were experimenting if robots can be done, and if it can be done in autonomous robots, can they do it algorithmically? So obviously they don't want to keep track on the robots, so the robots will perform this in 24 hours, because they don't, or maybe they have to do a little bit of rest, but most of the time they can go on, right? So we got these problems. And then also similar problem is also from Amazon, because they also have large depots, like sorry, large warehouses. So these warehouses can be very big actually. So it can consist of more than 10 football fields. It's a huge warehouses, and they maintain, so they have a lot of shelves. And when for example, I just give an example. Suppose you are ordering something, say a book on the Amazon, right? So there are a lot of process going on before it is delivered to you. So for example, even in the warehouse, what happens is that request will be picked up, and they will map it. So suppose you give a book. So for example, I don't know, maybe Rabindranath Thakur's Sanchoita, and then they will figure out in Sanchoita which. So they have a mapping. So to figure out, given this book, so what are the copies of Sanchoita available in my particular warehouse, and then they will find. Earlier, what used to happen is that the humans will go, so they will come from there and they will go to that places, and they have an inventory, clear inventory. So you'll find out, you'll go there and then figure out. Uh, so now they want to do it using autonomous robots. So what they will do, so there is a base station, you can say, or the depot. So all the robots are in the depot. So then the robots will go pick up something, and they will not immediately come back, because they typically handle a bunch of requests. So they will probably maybe one book from one shelf, then maybe one cosmetic from another shelf, then maybe some food from another shelf, like that. I mean, whatever is available in the depot. And then as long as their capacity permits, then they will be able to fulfill that. And exactly this problem, I'll go into details a little later, so you can get it in more details. So, but here are some of the examples that I have given. So robots picking up products in warehouses and bringing them to a depot. These are very relevant for like in Amazons or Flipkarts or eBay, or supermarkets like in Australia, Coles and Woolworths, or in India, for example, Spencer's or Big Bazaar earlier used to have it, then Reliance Smart and so on. So they exactly use these kind of things, and they want to automate this to save money, of course, and save on the employee cost, right? Because robots you have to spend only once. Then I work with the Defense Science and Technology Group here in Australia. So they are basically the research wing of the Australian Defence Forces. Now, Australian Defence Force they employ a lot of these drones and robots also, collecting surveillance data. So, for example, Australia is a huge country, and many of the places are quite remote and totally uninhabited by humans, right? So, for example, some of the maybe you can say illegal immigrants or something who doesn't have visa, they have no like legal documents, they want to come by boat or maybe some other things. By the way, in the US and other places everywhere, the border security forces like in India, they try to do that, right? So they try to stop people from coming from the border, right? And also, but it is very tough because the amount of border that you have is I mean, it's a huge area, right? And it's very difficult for humans to do a surveillance all the time, right? So drones are an excellent way because they can first of all go up. They are robots, but they are also flying robots. So they can go to uncharted territory and they have cameras, so they can take a lot of pictures of the things, and they can till their battery is there, so they can transmit that data in real time, right? So Australian Defence Force exactly does that thing. So they want to look for maybe illegal immigrants, the terrorists, or the criminals. Maybe some criminal they have done some crime. And the police is also very much interested in this. So they if some criminal is going there and hiding in a bushland or maybe hiding in agricultural space where maybe humans don't go, but if they if a like a drone, it is like a low hanging satellite, you can say, right? It is taking picture of all this terrain and it can give the picture in real time, so the military or the police can quickly catch some kind of terrorist or the criminals or illegal immigrants, right? So that's why they're very useful. Then there are autonomous vehicles that picks and drops people from their places, and maybe then the plumbers and electricians serving a group of houses. So as I said, right, robots doesn't always mean robots. So there are many different applications of this, and some of them were even studied before that robotic application come into place. So in mathematics and computer science, these have been studied. So for example, suppose I am a plumber or electrician. I start from my home after maybe having my breakfast at 8 o'clock. So maybe in one of the, I have some certain say plumbing job done in various houses, and then one of the houses, they say that I am available between 9 to 10. You have to come between that to do my do the work. Then maybe in some other places they may say that I am available between 11 to 1 and you have to come there. Somebody saying between 3 and 4 and like that. And maybe at the end of the day, maybe I'll come to my house at 6 o'clock or 7 o'clock in the evening, right? So this is also, I mean, though it may look like this is not very different, but in fundamental, in a mathematical sense, these are very similar. Okay, and these problems have already been studied in the operations research community or even in the computer science community for at least for the last 50 years. So, and we have the benefit of some of this knowledge from our great predecessors, right, who have done a lot of research on this area, and we can apply some of these ideas either directly with or with certain modification. And that's why I say that you should always look at other researchers and don't just focus on your thing. You get a lot of ideas from, because it's very unlikely that you are doing something completely new. I mean, there are so many smart people in this world, and also our great predecessors, right? They have also done a lot of research. You certainly get some ideas from them, and you can apply it into your settings. Then couriers transporting packages to homes and offices. This is also here. The couriers may be humans or maybe some like a postman or other kind of thing, but that is also very similar to this problem. Vans bringing groceries from local store to homes. So okay, so now initially I did not study, but then when I got the invitation, I thought that okay, let me do some study and try to figure out whether this has any applications in agriculture. So then I actually found in agriculture there are a lot of applications nowadays for the robot. So for example, fruit picking robots, where suppose you have an apple orchard or a orange garden or those kind of things, and these gardens are huge actually. They can contain acres and acres. I mean, maybe 2 square mile or 2 square kilometer. And earlier, of course, humans used to do that. It would take much longer time, and also humans get tired and so on. So now they are deploying, at least in developed countries like US or Canada or Australia. Australia also, because Australia is a very much agricultural society, there are a lot of farmlands there. So they deploy these robots so that they have specific capability to pick up foods, and then they have some kind of basket where they will put it there, right? So these also requires a lot of planning, because they deploy several robots, and that requires coordination and cooperation or collaboration between robots. Then driverless tractors, sheep shearing robots. So shearing means like you all wear sweaters, right? And it are made of wools, right? Particularly in earlier days, our mothers were used to do that for us from you. They'll take balls of wool and tail, but then you have to get the wool right from the sheep. So so earlier humans used to do it, but the robots are much more efficient and they can automatically shear the wool from the sheep. Okay, so that is also very useful. So in many of these settings in the agriculture shading, so you have these multi-robot systems, and the core of that multi-robot systems are actually multi-robot task collection, because you have to do task planning and coordinating and execution. Sorry. Then truck delivering goods from warehouses to supermarket. This is exactly the area I work on, because I work for the company called Optim, and so we basically work for our clients are so mostly American companies, American truck companies, then railroad companies and the airlines companies. So the kind of problem where I work on is that, so typically, and this is true pretty much anywhere in India, in Australia, in the US. So so you have the supermarkets and where you get a lot of stuffs on your shelves, but the thing is that how do you get this from the warehouses? So now what happens is that in the morning, for example, the trucks, they start from their depots. So for example, many of our some of our like clients, they are big truck companies, they have 5,000 trucks operating. Okay, now that truck starts in the morning from the depot, then they will go to warehouses, then collect some items. Note that your supermarket, suppose that is S and the warehouse is W and the depot is D. So from D to W, when we go, the supermarket has many things. It may not be available in one warehouse. So it may go to one warehouse, collect some item, then it may go to another warehouse, collect some item, and then maybe certain maybe 10 warehouses it collect them. And also not all the things will be go to one supermarket. Now they will collect from a set of warehouses and they will deliver them to again a set of supermarkets, and then they will come back finally at the depot. This is a very complex problem. Okay, requires a lot of scheduling and routing decision. So again, here trucks are still operated mostly, they are still not autonomous vehicles. These are still operated by human drivers, but the underlying fundamental mathematical problem is the same as the MRTA. So as I said, robots are not literally robots. This can be drones, it can be humans, it can be trucks and vans and so on. Okay, so and it has a lot of applications. These problems have like I'll say billions of dollars application. For example, we work at Optim for this thing. We sell millions of dollars by doing intelligent algorithms and route planning. These are tremendous applications in supply chain and logistic industry. Okay, and for one truck we save several $100,000 over the, and then if you have 5,000 truck, you can think about how much money we save. By even we can do it 1% or 2%. And though these problems are very hard, what is known as NP hard. Anyway, so let me see how I'm doing in time. Okay, so okay, now I think I have time. Okay, so now let us start with let us get to the real science of that thing. So I'll start with the MRTA taxonomy done by two very good researchers called Garke and Matari. So they put all these, so MRTA problems are quite complex. There are very different aspects of that. They put all of them into perspective and did a very nice taxonomy or classification of all the problems. So they basically divided the problems based on three different types. So one is the task type. So one axis in one of, so think of this as a three-dimensional space, all these problems. And you have on one axis, let's say maybe I don't know, x-axis, maybe you can call this is a robot type. So in the robot type, you have single task robot versus multitask robot. I'll explain all of this in detail in the next slide. In the another y-axis, you may have task type where you have either single robot task or the multi-robot task. And on the z-axis, you have allocation type based on, so this can be either instantaneous assignment or time extended assignment. Okay, so now let us get into the more details here. So this was the paper by them, a formal analysis and taxonomy of task allocation in multi-robot systems. It was published in the International Journal of Robotics Research. Now, in the first axis, it is like classified based on the task type. So either so it can be a task can be either a single robot task. What that means is that each task requires exactly one robot to achieve it or execute it. And contrast is a multi-robot task where each task may require multiple robots. So each task requiring single robot versus each task requiring multiple robots. On the second axis, it is based on the robot type you are dividing. So either you can have single task robot where each robot can execute only one task at a time, versus multitask robot where each robot can execute multiple tasks at it simultaneously at a time. So that means those robots have more capabilities, right? On the third axis, based on allocation type, you have instantaneous assignment where you when the robot comes, you are assigning allocating those tasks instantaneously to robots. And so when you are making a decision, there is no future planning for that. If something else comes, so you are not planned for that. So it's kind of a, you can say, a little bit myopic. Versus you have time extended assignment where each robot is allocated several tasks which must be executed according to a given schedule. So you have made a plan of all these robot. So when a task comes, each the schedule that you assign or the plan, so that is exactly done beforehand by a planner or the task scheduler, which is an algorithm. So obviously, so this is more it has you can say more far-reaching vision, right? Or it has it can look further in the future compared to instantaneous, which is much more myopic. Okay. If you have any questions, please clarify that, because it's going to be a little more harder. So you have to understand these things very carefully. This is like a very important part. So now, so what Garchian matrix is? Garchian matrix. So they also, based on these three axes, they classified this thing based on their complexity and hardness. And I'll go through all of them briefly, and then I'll show you a table at the end which will put everything into perspective. So let us start with the simplest thing. So you have this ST, MT, SR, MR, or IATA. So as you can see, so each of them are of two types. So the total number of possibilities are now 2 into 2 into 2, which is basically 8. So there are 8 different possibilities. And we will go through each of them slowly in detail. So the ST-SRIA, which is basically single task robot, single robot task, and instantaneous assignment problem, this is actually an instance of the optimal assignment problem in combinatorial optimization. And this is the only problem that can be solved efficiently in polynomial time. So that means among all the things, the simplest one, ST-SRIA, we can solve it in polynomial time, because this is exactly equivalent to the optimal assignment problem. So all the remaining problems are NP-hard. Okay, now you must have some knowledge about what is an NP-hard problem. So I don't want to do the exact definition of using Turing machines or the certificate thing, but in a imprecise sense, I don't want to get a formal definition. These are the set of problems which we believe, not the thing we have believe, we have no proof, formal proof. We believe that these problems cannot be solved in polynomial times. And since we always equate the notion of polynomial time with the notion of efficient algorithm, so again we believe that these problems don't have any efficient algorithm. So that means if the instance gets a larger, the algorithm that you make for the smaller instance, they will not scale. So for example, if you can probably solve it for 5 number of the input instance size n equal to say 5 or 10, but as it goes to 20, 50, 100, it's unlikely that you will be able to solve that and give an efficient algorithm. So your algorithm will not halt. Okay, so that's a very intuitive and informal thing. I don't want to go to the like technical details. There is a very nice technical details of that using Turing machines or the certificate, but you can look at it. So, but in a sense, these are the problems that we strongly believe that cannot be done, and there is a strong evidence that it's not just a belief like it's a religious belief or something. There are strong mathematical evidence to show that it is unlikely that there will be some breakthroughs in like in 50 years or so, unless there is a different kind of computational model. In the classical computing model, it is very unlikely that it can be solved. Maybe quantum, even quantum also, they think that it cannot be done. But anyway, that's a separate discussion for another day. Now, so that means then we are in a very tough regime, right? I mean, that is the only thing. The simplest version can be solved in polynomial time or efficiently, but all the remaining problems are NP-hard. But the thing is that as humans, we still have to solve this problem because all of them occur in real life, right? So I cannot just say that, okay, these are NP-hard, say, and my either in my my academic institute or my industry, then my manager asked me, and then, okay, no, I give up. This is NPR, so I cannot. Of course, it's NPR, but you still have to cope with the complexity, and you have to, okay, then I cannot solve it optimally, but can I solve it near optimally or some approximate solution? And that's what you'll try to do. Okay. So now let us go to try to understand the hardness of this problem. So the SRTA is single task robot, single robot task, time extended assignment. These involve determining a schedule of tasks for each robot. So this actually is an instance of a machine scheduling problem. Okay. Now, unfortunately, I cannot go through all the 8 problems. So basically, mathematically rigorous and correct way of doing this is show a reduction between them. Of course, I don't have time for doing the reduction for any one problem, let alone all the 8, but this is there in the original paper, or there are other references also dependent. So if you are interested, and it's a very interesting thing, if you want to know why these problems is hard, please send me an email after this thing. I'll point out to the relevant literature of the papers, or I can even give you some of these things, because I worked out some of these things. I can give those reductions also. Okay, but to really understand this, you should either look at the paper or work out the reduction yourself. But you can believe me, because this has been not only Gary and Marasik, many other researchers have looked at it, and they have, I myself also looked at it. I think this is quite convincing. Okay, but you should convince it for yourself. Okay, don't believe anyone, just apply your mind. Okay, so this is an instance of a machine scheduling problem. Now the STMRIA, which is single task robots, multi-robot task instantaneous assignment, this is a significantly harder problem, and this is also referred to as a coalition formation problem. Now this coalition formation, if you express this as a problem of partitioning the set of robots into non-overlapping sub-teams to perform the given task, this problem is equivalent to the well-known set partitioning problem. So for those of you who are aware of the set partitioning problem, STMRI problem, which is also the coalition formation of robots, which is exactly equivalent to the set partition problem, and so its complexity or hardness is the same as the set partitioning. The MTSRIA, multitask robot, single robot task, intelligent assignment, this is exactly equal to the STMRIA problem. Just you have to change the roles of the task and robot. So you just reverse the roles of task and robots, and it becomes the same as STMRIA. So that means it is also the same as the set partitioning problem. That's actually good. It makes life a little easier, because I don't have to keep track of 8. Already 2 of them are the same category. The STMRTA problem, which is single task robots, multi-robot tasks, time extended assignment, this involves both coalition formation as well as scheduling. So this is also equivalent to MTSRTA problem. Again, you just have to interchange the role of task and robot. Again, that's very good, because again 2 of the problem are coming to the same class, which is good for keeping track. So these are both instances of a multiprocessor scheduling problem. The MTMRTA, multitask robot, multi-robot task, time extended, this is an extremely difficult problem that actually this is the hardest problem in this class. So this can be thought of as an instance of a scheduling problem with multiprocessor tasks and multi-purpose machines. The MTMRIA problem, multitask robot, multi-robot task, instantaneous assignment. Here the goal is to compute a coalition of robots to perform each task, but a given robot may be assigned to more than one coalition. That means the robot may work on more than one task. So this problem actually can be expressed as an instance of the set cover problem for those of you who know. Now you may think that was set partitioning and this is set cover. Is it not similar or same? Right? So that's very tempting and confusing, but don't get into that trap, because they are not the same. The difference between the set cover and the set partitioning is that the subset of the robots need not be disjoint. Right, so that is the difference between set cover and set partitioning. Now, this is a lot of talk I have given, and this really cannot be frankly internalized or assimilated in such a short time. So that's why what I want all of you to go back to home and think carefully about this problem. Right? Why what I am saying, does it make sense, or I'm talking something garbage? Okay, or what the garbage, basically what I am saying is basically the what Gary and Marasik said, right? So you'll be able to convince yourself, if you work out through all the math, that these are exactly what they are saying. I mean, they are knowledgeable people, right? But to make life simpler, I have made a table. So you can see this table gives you high level overview of all this complexity at just at your front, right? And you will have a good understanding of that. So start with the STSRIA, which is the simplest of this class, and that is the optimal assignment, and that can be done in polynomial time. So that is the only problem for which know the efficient algorithm. And all the way you go through that, I'm not going to again repeating MTMRTA, which is the hardest of this problem. So this is called scheduling with multiprocessor task and multipurpose machine. And so yeah, so this is a extremely, even among NP-hard problems, not LP-hard problems are similar. So there are further categorization. Again, I don't want to get into that, but among NP-hard problems also, some problems are harder than the others. Okay, so MTMRTA is really a very hard problem, even among NP-hard problems. So now the thing is that now we may think that, okay, at least I have been able to say the last word on this MRTA, but unfortunately there are certain limitations which after this paper was published, many of the researchers realized that. So this taxonomy, it's a very broad taxonomy, but it cannot cover all types of MRTA problems. So that what does mean is that there are MRTA problems it doesn't fit in any of these categories. So you require more powerful taxonomies or more general taxonomies. So one such instance is that it does not captures problems where you have interrelated utilities and task constraints. So one of the notable class of such problems are MRTA problems which can be modeled as a multiple traveling salesman problem, or MTSP. So just to give a brief description of this, again, I cannot go into details, but you can ask me questions after that, or maybe send an email. In a TSP problem, you know, there is a traveling salesperson or traveling salesman. So he or she is sitting on a city, currently on a city, and he or she has to go to different cities and come back, so that the resulting cycle, it does not have any repeats any vertex, and which is also known as a Hamiltonian cycle. And so that the total cost of this cycle or the Hamiltonian cycle is minimized. Okay. So in a MTSP problem, so instead of one traveling salesperson, you have multiple traveling salesperson. Okay, so that is the difference. So it's just a generalization of the traveling salesperson. So in this case, what is happening is that the robots has to visit multiple locations to perform spatially distributed tasks, and the utility function is related to the routing cost. So the main problem with these things are, normally what happens is the utility functions are additive. So for example, if I suppose I am a person who are collecting money from, I'm collecting money from different houses or different places. I get 2 rupees from here, 5 rupees from here, 7 rupees from here. The total utility are typically additive. So when I go back to my home and then see what is my total I have collected, it is 2 plus 5 plus 7, like that. So that's an additive function. So in this case, the problem what is that for these kind of problems, there are kind of synergies or relationship or dependence between the tasks, and the total utility that a robot performs in this cluster task is not equal to the sum of its utilities. So it can be, for example, a different kind of function, maybe a concave function or that kind of thing. Again, I don't want to go into the details of this thing, but the thing is that it is non-additive. So that's why these things, this taxonomy cannot capture that. But unfortunately, such problems are quite common in robotics. So you cannot just say, I will not work on this problem. But so you should know that this particular taxonomy by Gary and Matas cannot handle that. So you need more general taxonomies to do that. And again, I don't want to discuss them in this talk, but you should know that this taxonomy has certain limitations. Now, if you have any questions at this point, I would like to ask it. Now, okay, you can tell me. I know I'm continuing, so you can. So here are some problems. These are closely related to MRTA. So the traveling salesman problems is also, this is probably one of the most important problem in combinatorial optimization. There is traveling purchaser or requirement problems. I would love to talk about a little bit. These are very interesting problems, and these happens in your everyday. You believe it or not. For example, just give you a brief about what is a traveling purchaser problem. Suppose you are a customer and you have choices of buying goods from several shops or supermarket. Okay, so same shop, for example, Apple, in one supermarket it can be costing maybe 100 rupees per kg. Another supermarket it can be costing 120 rupees per kg. Another it may be costing 90 rupees per kg. Similarly, you may have the bananas costing different things. maybe cucumber, onion or something. But it's not that in one supermarket everything is more costly than another supermarket. It can vary. Now you have a car, you want to go from house, and then of course you have a cost also to go to the supermarkets, right? So what you really want to do, suppose, and you have to buy a bunch of things. For example, maybe 1 kg apple, 2 kg orange, maybe 1 kg banana, maybe 1 kg cucumber, 2 kg onions, 1 kg potato, and then you want to purchase all of this for all the supermarkets, such that the total cost of your like purchase of all these items, plus the total cost of the, because you also go to from different supermarkets, you are paying petrol on that, right? Plus the total petrol cost on your vehicle is minimized. That is exactly what you want as a customer, right?
So I discovered fine.
Oh, okay. Yeah. Just I'll talk to you. Yeah. So now, as a customer, you want to minimize that thing, right? Because you want to save money, because saving money is very important, right? I don't have to tell you that. So this is this is called a traveling purchase problem, which is also a very important problem in the supply chain and logistics. So then there are vehicle routing problems, scheduling jobs on machines, multi-commodity flow, assignment, bipartite and general graph matching problems. So all of them are fundamental problems in optimization or operations research. And these problems, MRT is actually very closely related to all these problems. So as I said, you have to know the context under which you're operating, and you have to know which are the important problems with which this problem is related. Just the way in human society, you want to do some good things, but you want to also be in close proximity and in good relations with the important people in this, in your, particularly in your local context on the society, right? So similarly, in the problems also, you have to know this is my problem, it's an important problem, but how they are related to other closely studied and well studied and important problems. Okay, now if you don't have any questions at this point, I would like to go and present one of the are there any questions? Okay.
Yes, we have one question from Dr.
Okay.
Shantini.
Okay.
Just
So,
wait.
as you have mentioned so many problems, so I have just a little bit curious about, as it is a multi-agent system, that means so many robots may work together. So, which of the problem makes sure that not two of the robots get collide?
Okay, so that's a good question. Now, this problem of robot colliding, that is, see, so typically, so suppose this is happening, for example, on a agriculture field or a warehouse. So typically, we consider this as a three-dimensional Euclidean space. Okay. Now, in the three-dimensional Euclidean space, of course, if the robots try to move randomly with each other, so there will be collisions. But typically, we impose more structure on that, and then we make this as what is known as a graph, and then make the distance as a metric. So we call this a metric space. So here, now the robots and all the sides of these like items. So the racks, for example, and the depot. So all these are, like, you can say, also consider one vertex or node, and the robots are moving from one node to another. Now, when they are operating in this particular the space created by the graphs and the underlying distance function, so then there is no question of any in that, you can say, logical space, there is no collision. But in the physical space, there can be collisions, because maybe the robots are going in certain velocity that they can run into each other. So that is not exactly the problem of the MRTA. It is more of the problem of the collision avoidance detection system. Okay. So that particular module of this, as I said, MRTA is multi-robot systems are a complex piece of thing. Now that particular module of this system, that will be able to handle that. So the collision avoidance and the collision detection system, and they will make sure that there is no collision avoidance. So MRTA's job is to do the task planning, to actually, when they go there, when there is not a collision, so that particular piece of the module will take care of that. Does that answer your question?
Yes, yes, sir. That means these robots are totally controlled by a separate segments, right, sir?
Yes. So for example, I mean, I can give you some like idea about how. So each of the robots has cameras, for example, and also sensors. They can sense within their certain maybe within their 1 meter whether there is anything, any other obstacle or robots are not there. When there is there, so they will move their path or move their directions to avoid those things, and it can be a moving object also, like another robot. So and they will correct their course, and then they will avoid that. But that is a different kind of idea. So this requires more ideas from computational geometry and other kind of things. So that is part of the path planning things, where you are building the physical path. Okay.
Okay, sir. So can we design this system with completely ad hoc manner that they take decisions by their own? Is it possible, or it will be very much complicated?
I mean, you are talking about a multi-robot system,
Yes,
complete
sir.
multi-robot system. No, that is actually a complex thing to do. I mean, because there are a lot of aspects of having a multi-robot system. The kind of system that, for example, Amazon operates, it's a very complex system. So they probably in their warehouses there will be hundreds of robots, and with maybe thousands of sites, or maybe even 100,000s of sites. So that kind of things are. But you can probably in your laboratory you can try to make a system with 2 or 3 robots, and then maybe you can put say maybe 10 objects there, and you can apply some of these algorithms in that setting. But then you also have to use the collision detection and other kind of things yourself. And so there is an I don't know whether it's familiar or not. There is an operating system called ROS, the robot operating system. So where some of these functions are available maybe as a inbuilt library, so you can use that. Okay, for example, when we designed this MRTA part, we only wrote the algorithms for this task allocation. So then there was another team in our group who does this kind of actuation or this path planning or collision avoidance. So they took our thing, and then they made sure that physically when the robots go there, I said logically it should go from there and this order, physically how it will go. Okay, so that's a separate component, you can say.
Okay, sir. Thank you.
Okay, thank you. Okay, let's go back to this. And this is one work we did a little earlier, not too far earlier. So it was published in this current robotics reports by some of my collaborators. I'll mention their name at the end. So this is a very general formulation of how to model this kind of things. So let me go through that. Okay, how much time I have? Okay. So you have a set of n robots, and so R is a set of n robots and T is a set of m tasks. So in addition, you have certain other functions. So these are important to model this thing. So because T I have taken as task, so I could not use T as time. So I use tau instead as time, because there are a lot of symbols there, and I have to manage them carefully so that there is no conflict. So that's very important when you write mathematical papers. So give intuitive name, preferably their first letter, but also make sure that there is no conflict in that. So tau is the time. So S or tau is the state of the robot R at time tau. Similarly, ST tau is the state of the task T at time tau, and AC tau is the state of the environment E at time tau. Now, of course, robot and task, you know what is an environment. So environment is basically, so we try to so in addition to the task and robots, there are other aspects of the environment or the surroundings of the thing, right, where the robot is operating. So we capture this information regarding a dynamically changing environment using this function. So which, for example, includes the transition cost between task and robots and certain dynamic factors that may affect robot communication. Now, this is for the dynamic case where it is varying with time tau. If it is a static case where the system does not change over time, then we simply drop the function tau or the bracket tau, and you just say SR, ST, SC. That is a much simpler scenario, but we model it in the most general manner. Okay, so it can capture both static and dynamic environment. Now, to perform a task T, a robot R will do two things. It will incur a cost, which is represented by a function of this cost C, SR tau, ST tau, and SC tau. and which will also receive a reward, which is again a function v of this SR tau, ST tau, and AC tau. So they are both function of these three functions. Now they both depend on the states, and then we combine this cost and reward in terms of an utility function, which is basically again a function of TV. So it's quite complex, right? So C and V dependent on SRT, and U is dependent on that. So to quantify a robot's preference over a particular task. So this is the utility function which we are after. Okay. So this is one function which we want to maximize. Okay, because utility is what I want, maximum utility for myself. So everyone likes to maximize their utility, right? We also want to do that. So in addition, robots and tasks can have certain constraints, because nothing is free in this world, right? So you may have fixed amount of petrol, or maybe fixed amount of money, or fixed amount of budget that you are allocated for a certain things, right, and so on. The objective function that we have to do something with that, right? Because we want to we just want to give some solution, we want to give an optimal solution. The objective function is based on any combination of this cost, reward, or other goals. And the goal of the MRTA is to allocate tasks to the robots, while you have to respect all these constants, because you cannot violate those constants, and then you have to optimize the objective functions. Depending on the scenario, you may either minimize this or maximize this. So in addition to that, it is complicated by there are other kind of things that complicates matters. So not all robots can do all the things. Okay, so just the way every human cannot do everything. A robot, not all robots can do all the things. So a robot can. So that's what we map this thing by what is known as a skill. So a robot can have one or more skills, which we call phi. Okay. And also a task may require a robot of a particular skill, or multiple robots with a combination of skills. Okay. So a task may require a set of skills to perform that. So I'll show you a little short example. Some tasks may require moving some object. Some tasks may require pulling some object. Some require pulling some object, and things like that. Now we model this set of all skills at the capital phi, which is the set of all such skills. A robot R, suppose it is at the state R, state SR, so it can be represented as a tuple phi R BR, where phi R is the set of skills of the robot. For example, it may be able to lift something, or move something, or push something, and so on. And BR is the available budget of R to perform tasks. So the robot cannot perform independently. Maybe it has a battery constraint, or maybe it has a distance constraint, it can only go so far, or maybe it has a constraint that it can at most carry from like certain amount of weights, and so on. So these are the available budgets for every task. So for every task you have it requires certain skill set. So for example, and it is a set of pairs, for each pair consists of a skill phi and its corresponding demand. So the demand means that I require this particular phi. For example, I require maybe pushing something to the amount of 3, pulling something to the amount of 10, like this. So that demand is this requires how much I need for that particular type of skill. And for robot R to perform task T, which requires skill phi, it must have sufficient budget BR to satisfy the demand D phi. Now this looks quite complex when you talk about abstract notations and math, but I will give you an example which will illustrate this and clear this thing very well. So let us look at this particular illustrative example. So to simplify matters, I have just taken 2 robots. So they are R1 and R2. And we have 3 tasks, T1, T2 and T3. And all of them are sitting in, suppose in the normal Euclidean, 2-dimensional Euclidean space, or maybe the Euclidean plane, because 2-dimensional Euclidean plane. So now, and there are distances between the task and robots as well as the different tasks. Now the thing is that, note that the robots are not homogeneous. The robot R1, it can only push, and this has the capability of 4 units of pushing. So it can, it has the capability, it can only do 4 units of pushing. So robot R2, it can do both push and pull, and it can do like 6 units of push and pull. Task T1, it requires 3 units of pushing and 3 units of pulling. Task T2 requires 3 units of pushing, and task T3 requires 1 unit of pull. Okay, now you can see that. So in even this simple example, it is not very tough to find out a feasible solution. So for example, the robot R1 can go to task T1, so it incurs a distance, this d R1 T1, and then, so because it has push amount of 4, so it can, and this task T1 required 3 units of push, so it can give 3 units of push and it will still remain 1 unit of push at its disposal. Task, robot R2, it goes from the from this place to T3, and that requires a 1 unit of pull, so it has available, so it gives 1 unit of pull, and then from T3 it goes to T1 and incurs goes a distance T3 T1. So here it gives it a amount of 3 units of push. Now, 3 units of pull, because already R1 has provided 3 units of push and R2 has now provided 3 units of pull, so it T1 will be satisfied. T3 has already been satisfied. Now the R2 goes to, so it still has 3 units of push left, and R1 only has 1 unit of push left, so it cannot satisfy T2, but R2 can satisfy T2 because it has 3 units of push available. So it now goes to T2, incurring this T1, T2, but now it satisfies this 3 unit of push. Now all of them can be satisfied. So in a complex situation where there are hundreds of robots and thousands of tasks, this is very, very non-trivial, as you can see, right? See here, because it's a simple situation, and it's like exponential, like you have to consider so many possibilities. As you can see, it's very, very tough. Okay, so this is a toy example just to show that what is the situation, but in real life things are very hard. Okay, now so there are many different kind of MRTA solution approaches that has been discussed in the literature, and we studied some of them, but there are many more. I mean, we studied when we were doing the research. Now we have not studied in this talk, but I would like to tell you some of these things which we can go home and read further, or you can give me, send me an email, and I can point you to the relevant literature. So depending on the type of processing, it can be either centralized or decentralized or distributed. Okay, the kind of task planning you are doing. In terms of the methods, it can be optimization based, and among optimization based, you can have deterministic, and typically they are exact algorithm, and then there are stochastic things which are more randomized, as well as heuristics which are more approximate. So they don't need optimal solution, but the deterministic solution may not be very scalable for large instances. There are market based or game theory based solutions. So among them, there are auction based algorithms and negotiation based algorithms. So we studied some of these very interesting auction based algorithms, but unfortunately I don't have time to discuss them. So, but there are very interesting this market based algorithm also to solve this thing, particularly in a distributed manner. So actually it is much harder to study it in a distributed setting, because the robots have to make their own decision versus in a centralized setting, as you can see, right? And then if there are fault tolerance aspects involved, it makes even more complex. It's very, very complex actually, right? In fact, there are very few algorithms known which are fully distributed and fully fault tolerant. So you have a lot of chance to do original research here. Okay, so mostly we studied centralized and some decentralized algorithm, but and no fault tolerance. With fault tolerance, things get much harder. Then there are other methods, for example, learning based, behavior based, or hybrid, which are combinations of some of these techniques. So the literature here is quite rich. Okay, and if you are interested, you can. I definitely welcome you to look at some of these. Now I will conclude this talk with a concrete algorithm example that we developed for this problem. So one particular example, and it will give you a very good understanding of this problem in a very concrete setting. So this is the problem of robots and drones working in a warehouse. For example, the kind of warehouse I mentioned, like the kind of large warehouse maintained by companies like Amazon or Flipkart or eBay. Okay, so here they maintain both robots. For example, there's this kind of a IK, inverse kinematic hands. So these robots will start from the depot. It will maneuver through the passage between these racks, and it will identify this because it has the number given this particular item in which rack. So basically, you can think of this as some kind of a maybe 3-dimensional grid. So where 2-dimension XY is going to the base location, and the 3rd dimension shows in which rack. So it's like XYZ, you can think. So it goes there, and it can read also that particular, because there is either some kind of a QR code or a RFID tag. So it can actually read and find out this is the book or this is the item I want. So it goes there, picks it up, and then it maybe try to collect them and then put it in its bag and so on. But we are not that interested in that. We are interested in the planning part of that thing. But it can do that. It has the capability to pick it up, and then it will collect. For example, it can collect 5 things till its capability exceeds. So for example, say it can carry 100 kilogram, and then total weight has become 98, and then there is next one is 10 kg. It cannot handle that. So it stop there and pick up all of them. Okay. And similarly, now if you have a drone, so whereas they operate drones also, because you can see drones can go faster because they can fly. So they don't have to go through the maze of the thing. They can just identify on top of that, maybe in a angular manner, or in a direct way, right? So whether the robot is slower, so drones are even faster, and they have those same principles. They pick up the boxes and they give it back to the depot. Okay, so just you have to understand a little bit about the domain, in which domain we are operating, right? So in addition to the math part, you have to understand the domain part of this thing, so that you can do the math better. So now, a warehouse is typically spread across a very large area. As I said, it can be the size of several football fields, and these are huge. I have been to one of such warehouses in Amazon here in Sydney, and they are really, really huge. Of course, I don't want to collect these things myself. I'll take many hours. So it's better to do these things for automation, for drones to do that. Earlier, when they were small, humans could manage it, but it is getting as more and more people are going online, and they are writing more and more items. It's becoming extremely, I mean, not at all scalable for humans to keep track. So only, I mean, automated solutions like robots can do that, or drones. Now, these items are stored in storage racks across this vast area, and then the number of storage racks are so huge, right? You'll get lost. I mean, this is like a maze, and if somebody hides another part of it, you'll have no chance of figuring that out. He or she can hide them forever. It's so big and so complex, it's a 3-dimensional maze. So now, suppose you order an item on Amazon, and then the item is scheduled to be dispatched. And then what will the robot do? It will fetch the items from the racks because it has the information. So there is another algorithm which is doing the mapping between the items that you ordered online and what exactly is the rack where it will go, right? And it will collect all such items from the racks, and it will go to the packaging dock. Now, in this case, we have considered a simplified thing. For example, when I started this job at TCS, at that time, I did not even know about Gary and Matisic's taxonomy. So we started with a simpler version where we took a homogeneous robot, and each has a maximum capacity to carry weights. For example, say 100 kg. And the tasks are also homogeneous, but they differ based on the storage location or weight of the item. For example, so some task may be sitting at a particular storage location at a certain coordinate, and it has a weight of 10 kg. Another task in another place in the Euclidean plane with 20 kg, like that. Okay. And the most important thing is that these tasks are handled as a wave, where a wave can contain thousands of tasks. So it is similar to, you can say, in computer science we call batch processing versus real-time processing or instantaneous thing, right? So where when a job is submitted, in one case you have to process it immediately. In another case, you can create a group or batch of the things and then execute all of them together. So in this case, it is much more efficient to do it as a wave or a batch, because when you collect the items, you can plan them. For example, there are a lot of, you can group them based on whether a lot of them are in nearby racks, and you can collect them as a whole. But say if you go, a robot comes and come back and immediately go to another rack which is very nearby, it's just wasting its distance, because if it is when it is operating on battery, it is wasting power, right? So you don't want to waste power. You want to do it in an efficient manner. So once all these tests are complete, the next wave comes, so where all the another set of customers are given the recommend, and then the algorithm makes a plan based on that, and then it executes that thing, and then collect all the things and together all this robot and come back to the depot. Okay, that's a very efficient way of doing things rather than doing it one by one robot, right? So you makes a very nice, it's an efficient plan of the thing. So whole thing, it will be much more cost effective and close to optimal. So So okay, here is a diagram. I just illustrated on a two-dimensional Euclidean pen. So suppose 0, the number 0, sorry, place 0, it is at the center, that is the depot, and this is sorry, this is the my situation on a simple grid. Okay, so then these items are placed on these grid locations. Okay, and then suppose you have a bunch of robots, couple of robots, and then each of them will go and collect them. And I want to optimize this thing. Okay, so I have shown one such plan where I have marked for clarity different robots with different colors. So for example, the red robot can start at 0. So remember, all of them are at 0 and all of them are will come back to 0. It goes to 7. Oh, sorry. It goes to 7, then 1, 4, 3, and comes back to the depot 0. So it has picked up these 4 items. The blue robots go from 0 to 8, 6, 2, 5, and comes back to depot, and like that. So in these instances, I see that all of them have exactly 4 things, but it need not be the case. It's just a coincidence. So some of them may pick 5 things, some of them are same as 7, some of them maybe 2, like that. In this case, it's just a coincidence. So now you can see this is the kind of scenario. It's a simplified version of the scenario that we are talking. So the important thing, you have any questions on this? So the important thing is that you can interrupt me.
Anyone having any question?
Anyway, so anyway, so you can tell me later also. The important thing is that when you looked at the problem, you are thinking, of course, because this is a new problem. Of course, nobody has told me. No, we don't have any professor now, right? Yeah, at least when you have a supervisor or teacher, they can tell you, okay, but because we are on our own, right? When you are in the job, right? So you have to do it yourself. So nobody told us a thing. So of course, we did study a lot of literature, and then we found, so there is a problem which people have studied actually, I mean, like 20, 30 years or 40 years back in the operations research and supply chain. So they solved this problem called the vehicle routing problem. And of course, vehicle routing is a very general problem. So one particular variant of the problem, a special case, the capacity constant vehicle routing problem, which is also known as CVRP, it looks similar to this particular version of the multi-robot task allocation problem. And so we, of course, investigated more and tried to figure out how we can use this some ideas from that problem to solve this problem. Okay. So let us now try to formalize this as a precise mathematical problem. And this work was published. So with my TCS collaborator, I mean, when I was a research scientist there, Choyon and Himadri. In fact, Choyon introduced me to this problem, and I am forever grateful to him, because I have worked on many such problems, not only in TCS but also in Australia with UNSW Sydney and CSR and other places. So we worked on this problem for about 1 year, and then we could publish one good paper, a scalable multi-robot task allocation algorithm in the IEEE International Conference on Robotics and Automation, which is like the top conference in robotics. So anyway, I just want to give a brief overview of that, because I cannot, of course, give you all the details, but I have to give the crux of the idea, the core idea. So here, so we are modeling this Euclidean space. In fact, our algorithm is very general. It doesn't only work on the Euclidean space, I mean d-dimensional Euclidean space, but it can also any metric space. Okay, so okay, so I'll go to what is the metric space. So so here G is an undirected complete graph, and we denote the vertices as V, which is V0, V1, Vn. Now the special vertex V0 corresponds to the depot, and the other vertices correspond to the n sites associated with the task. So in this example, the vertex 0 is the depot, okay, and all the other vertices, these are what the tasks are. So again, task is a very general concept. In a warehouse, it is your task is the task of picking up the items and delivering it to the depot, right? In other setting, it can be different, but we have modeled it in a very general manner. So these tasks are located on those particular vertices. Okay. In the Euclidean space, the distance between two will be the Euclidean distance. In other space, the corresponding application will define what is the underlying distance. Now each AG has a cost C. So in this case, the cost, suppose for example 0 to 7, it is the Euclidean distance. How do you do that between x1 y1 and x2 y2? You just do the x2 minus x1 whole square plus y2 minus y1 whole square root of that, right? But in other space it will be different. So that is the distance function or the cost function we have. And for each vertex, there is an associated demand di that must be satisfied. For example, in the case of Amazon warehouses, the demand is that robot will be able to pick up that particular item with a weight, say wi. The number of so we have so of course the number of robots are not infinite, right? Because each robot costs money, and one of the goal was to do this job with as little number of robots or as the minimum number of robots that is possible, right? So suppose the number of robots available at the depot is k. So in this case, for example, I can do it with 4 robots, so k equal to 4. So this diagram is very illustrative, so you can get the mapping of the math with the picture. So that gives a very good understanding. And I always said that, right? I always try to do pedagogical aspects. So I want to do the conceptual aspect, very important. So the capacity of each robot is C. So for example, maybe as I said, each robot can carry 100 kg, and there are all these items situated there. Some are 20 kg, some are 30 kg, 50 kg, like that. And the robot has to pick up such that at no point in its tool it can have more than 100 kg. So that's because it will break then. And the maximum demand of any vertex is at most the capacity of each robot. Now that has to be there, right? For example, if like all the robots are 100 kg and there is one item which is 105 kg, no robot can operate that, right? It has to be broken. I mean, either robot will break or the item has to be break, and they are indivisible. So that is not a legal a valid instance of the problem, right? So without loss of generality, we assume that each of the item can be carried by one robot. Okay. And at that time, again, I did not know about the Garchian matrix astronomy, but then when I later studied, then you can convince them the thing I have shown, and you go back. This is an instance of the MTSRTF problem. Okay. Now, what is the objective? So the objective is to, if you model this thing now in terms of the graph theory, so the objective is to find a set of vertex discharge cycle except at the depot. Of course, they started at the depot, so they are coming back at the depot. So there will be a common point, but that is the only common point, because it is at no point it will happen. A robot has visited and collected a item, then another robot will go. That doesn't make any sense. That a repetition. That's a wastage of time, right? Or wastage of my resources. So as you can see that all the cycles, they are disjoint except at the depot. So that is exactly what this is in a mathematical term, right? So find a set of vertex disjoint cycle except at the depot such that the total cost of the cycle is minimized and the total demand of all the vertices in each cycle does not exceed the capacity of any robot. So what does it mean is that, so for example, this green robot, it has gone to 12, 11, 15 and 13. It has 100 kilo. If 12 is 20, 11 is 30, this one is 15 is 20, and this one is maybe 10. This is I think it was 80, so it is okay. But if the total sum is like 120, it is not a legal thing, because the robot cannot simply carry it, right? So that's exactly, it's a very simple thing. Just map it in a concrete instant. You will find the math is very simple. And it is just abstract way. You mathematician like to write it in a very nice, in a precise manner. But the intuition is more important than the symbols. Okay, always keep that in mind. Now, and then I wrote something in a very precise mathematical thing, but it's exactly what is I have shown in the. So in other words, we have to find T cycles which is less than or equal to K. Why? Because I have only K robots. I cannot do it with more than K robots, right? Actually, there is a small caveat in that. I'll explain it a little more later. Such that the total sum of the sigma CCI is minimized, which is exactly the sum of the cost of all the 4 cycles here. CI intersection Cj is V naught. Exactly, that means that the set of vertex disjoint cycle except at the depot. So their intersection only is at the depot, and the total cost of a cycle is less than or equal to the capacity of that. Okay. Now, so I'll briefly mention the algorithm that we created, which is basically heuristic. So we could not prove an optimal. So first of all, it's not possible to have an optimal because an NP had problem. So, but we could not also prove any approximation guarantee. But in practice, it works very well. In fact, it was better than even some of the existing heuristics. So the algorithm that we designed is, I think, how much time? 1023. Anyway, I think hopefully, because we already has questions and we can. I hope if we take 5 minutes more, it will not matter. So nearest neighbor based clustering and routing. So here what we do is that this NCAD, so this algorithm, it splits all the nodes into a number of clusters. Okay, for example, in this case, you can think of the algorithm divides this into this cluster of red cluster, blue cluster, green cluster. So how does it gather? That is, you should read the paper, because I don't have a lot of time to do that. So definitely all the details in the paper. So, and the content disjoint set of nodes except the depot. Okay, so of course, because depot is that is nothing in the depot, that's the robots are there. The items are on the vertices. Okay, now the important thing is that the nodes within a cluster should form a feasible route. Now, what is a feasible route? The total demand is less than or equal to C, because if the total demand is more than C, the robot cannot carry it, so it's not feasible. Now, the cluster we form in a certain way so that the path cost of individual clusters will result in a lower total cost path. Okay. Now, so basically what I do, the idea is the following. Suppose I am at a vertex 7. I look at the nearest cluster. Nearest means in the sense of a nearest distance. So for example, if it's a Euclidean distance, I compute to all the Euclidean distance to all the other things and which are not allocated till now, and find out that one which is the nearest, such that if I add this thing, the current cluster total demand plus this neighbor demand should be within the capacity limit. Suppose I find a very near distance, but now my current thing is 80 and the robot capacity is 100, and this one has weight 30. Now 80 plus 30 is 110, which is more than 100. So that's not a feasible cluster. So though it is nearest, I cannot include it. So I have to leave that and go for the next nearest. And then I want to continue to do that till I found the nearest cluster, which when added to this will still remain the route feasible. Okay, it's very simple. There is nothing rocket science here. Very simple intuitive algorithm. And so it requires some other things. So now suppose I found a set of clusters. Okay, how do I construct the route? I construct this. So this is exactly an instance of a traveling salesman problem. So what we do is that, again, TSP is an NP-hard problem, so we cannot solve it exactly. But there are well-known approximation algorithm. For example, there is the Euler tool-based algorithm, which gives two approximation, and then there is a algorithm called Christophidis algorithm, which is the current world champion. I think it was in 1971. Still, it is the best. So we use the Christophidis algorithm for each of them to get a 1.5 approximation. So we are not very far away from the optimal, only 1.5 times, and we cannot do anything better because that's the current state of the knowledge.
Sir, Devasmita Roy is asking that is there any formula for robots that if capacity is more than 100, then robots should not visit any more node or vertices?
No, so see, I mean, so suppose no, there is no like formula that you can compute here. So basically, what? So suppose, so I am a robot, I am traveling, and I'm exporting my thing, and I'm collecting items. Okay, at some point, I found the nearest neighbor. If I add it, it will exceed 100. So I drop that, but there may be other, there may be another robot or maybe a set of other items which I can still collect. They are not the nearest, but maybe the second nearest or the third nearest, right? So I have to continue to search for them. I don't know at this point whether I cannot add anything else. Okay. So I mean, I cannot give it up. There is no formula. So I have to look for the next nearest and see I can add it or not. If not, I can third nearest, I can do that. I have to continue the search, right? Till I can find that something I can get. Suppose I look at all of them and none of them can be added. At that point, I can say, okay, no, this is the final set of things that I can carry. Okay. Okay. So it requires some other thing, like you have to compute a Euler cycle on that and then do a TSP. So all the details on the paper, but this is the high level idea. It's not a very complex algorithm, but it's an intelligent algorithm. So that's why you should come up with simple ideas. It's not very complex, but it can still be a very smart algorithm. Now, so now how do I do the running time and quality of the? So NCAD returns three things: the number of robots request to visit all the nodes, the route of each robot as a sequence of nodes, because those are the paths in that, the total cost to travel all the routes. Okay. Now we analyze the time complexity. Of course, as a computer science student, you should always analyze the time complexity because it's the one of the most important things. And the running time, the order notation. So this is not just a book thing, right? This is a very important real life also. So time complexity is order n cube. The total cost of all the routes produced by NCAD is within a factor of 1.25 to 1.5 to that of the optimal solution opt. And I'll show how the opt comes because it's NP hard, right? So I'll give that thing in a minute. And the number of robots required to visit all the nodes by NCAD is almost always the same as that needed by the optimal solution. Okay, now let us go into some of the details of the experiments. So we evaluate using 3 different metrics. The most important is the cost of the solution. That's the first thing. Then the number of routes in the solution, which is similar to same as the number of robots, and the execution time of the algorithm. Right? So these are in the order of importance. These are the 3 objectives. The cost of the solution is the total distance traveled by all the robots to visit all the nodes. Okay, that is clear. Now there is one caveat that I mentioned, that is, suppose there are 10 robots and there are 13 routes that you have found. Okay, now, so of course, because you cannot parallelly do it, because you cannot assign 10 robots simultaneously to 13 routes, because by pigeonhole principle you have more than routes than the thing, right? So some robot has to do twice. So what we can do is that see, if there are not all the routes, if it is less, what we can do is that, so suppose there are, let's say that's very simplest case. So you have 3 routes and 2 robots. So one robot, so suppose the route is R1, route is also R1, robot is R1. That's not, maybe it's called cycle. C1, C2, C3 and R1, R2. So R1 say visits C1 and R2 visits C2. Now after R1 or R2, whichever completes first, it now goes on to explore C3. Okay, so now what is happened when the number of robots is less than the number of routes, it is actually a time extended thing. So for example, I complete my my tour and then I go on to do another tour. Okay, so that's what a robot starts a new route after completing the previous assigned route. So it is good in a way, the number of robots are reduced, but the bad thing is that it is now increasing the time, right? So the time of the whole solution or the whole thing is that the execution time of the algorithm plus the execution time of the algorithm is actually computing the this task assignment plus the actually doing the this robot thing, right? I mean the so if you have a time extended, suppose you had 3 robots, then they can do all together and the total time will be max of the 3 times. But in this case, it will be one robot will go 2 times, so it will be serially added. So 2 things are parallel. One of them is one after another, and this thing just directly that. So it will increase the time, right? So that is the trade-off between the two. So you have less cost for the robot because you have less number of robots, but the time is getting here. But time is also very important because in a such a large warehouses with millions of orders coming. Now we evaluate this performance of NCAD for some well-known. Okay, so let me tell you what is the CVRP benchmark that we use. That is very important, and you can also do these things yourself. Okay, so of course we need some instances, well-known instances whose optimal solutions are known. Okay, now this exactly that thing can be found in what is known as the CVRP library. So what is happened is that people over many years, some of the greatest researchers and professors in this area, like Papa Dimitru and there are other things on the Lawler and many of the things, they have done research on TSP or VRP. So they have by various means, branch and bound techniques in integer programming or cutting plane techniques and things like that. They have been able to find out the optimal solutions of several problems. And they have given that thing, that what is the instance of the problem and what is the optimal solution there in the CVRP library, right? So we took some of these such instances and whose optimal solution is known, and we compared that from the CVRP library with Google Optimization Toolbox, which we call What Tools, which is like one of the very good, like you can say one of the world leader in this area, and our algorithm, which is a simple algorithm called NCAD. The cost ratio is basically the cost of the algorithmic solution and divided by the cost of the optimal solution. So alpha for What Tools will be ALGOAD by opt, and alpha for NCAD will be NCAD by opt. Okay, and we want to do it as slow as possible. Now here are some experimental analysis. So as you can see, we are varying the number of nodes as well as the number of robots. The what tools is performing better compared to NCAD. You can see the red one is what tools and the blue one is NCAD. So what tool, for example, do can you have between 1 to 1.2, whereas NCAD is doing between 1 to 1.4. So you are performing slightly worse. But now, if you look at the execution time, what tool is the red line? It is not at all scalable. So, for example, n equal to 16, the what tool is at something like 10, and the hours is almost close to 0. It's not 0, of course, but it is. I think we could not show that extent. But now, head is doing our thing is almost scaling linearly for n equal to 101 and or maybe 100 and k equal to 4. It is taking about, I would say, 10 milliseconds, whereas what tool has already gone to close to maybe 190 or something, right? So it is not a scalable algorithm. So for larger instances, it's taking a lot more time. So that is the price you pay for close to near optimal solutions. The execution time is very high. Now, if you look at the total cost for large number of nodes, as you can see, the cost that you are getting, actually you are performing better in many of the instances as the instance is increased. So for example, at lower cost, what tools is very good, but at lower number of nodes, what tools is very good, but when the number of nodes increase, NCAD is actually doing much better. For example, here it is taking 30,000, cost is 30,000, whereas what tool is taking more than 40,000. The execution time for large number of nodes, as you can see, suppose n is equal to 2000 and k is equal to 400. So what NCAD is taking 50 second, whereas what tool is taking.
Sorry to interrupt. Just to inform you that the speaker of next session, Dr. Sandeep Chakraborty, has joined us.
Okay.
Just to inform.
Okay. Okay. So I'll just finish it. Okay. What happened? Yeah. Just I'll finish it quickly. Okay. So okay, I'll not go to the details. So just to give you a brief analysis and insight of this. So as the number of nodes increase, NCAD consistently gives lowest cost solutions, and what tools requires a significantly higher execution time, and which increases a lot when the number of nodes in the CVRP instance increases. And NCAD also consistently produces fewer routes, which is also advantageous because fewer routes means fewer number of robots and saving in the cost of the thing. Okay. And the effectiveness of NCAD is magnified a lot if the cost of the solution is measured in terms of maximum route length across all the robots and tasks. Okay, so I wanted to go briefly through of the other problems that I am working with my collaborators at UNSW Sydney and Defense Science and Technology Group, but in the interest of time, I'll skip them. These are also very interesting problems. Now I'll just conclude that talk and some future direction. So first of all, as you see, MRT is a very complex problem with different dimensions, right? It has a lot of things there, and there are many things to work on it. And as you say, out of 8 versions, 7 variants of the problems are NP-hard. So only one problem can be solved in polynomial. That means they're efficient algorithms. So MRT has very intimate connections with several important problems in combinatorial optimization. For example, traveling salesman problem, traveling purchaser problem, vehicle routing problem, and so on. So we designed a scalable and near optimal algorithm NCAR for a particular version of MRTA, which can be related to the capacity and vehicle routing problem. So how can we improve NCAR both from the theoretical perspective by proving an approximation guarantee and practically also by improving it even better? We are also working on related version of the problem called orienteering, deadline TSP, and vehicle routing in time window. And yeah, so okay, the last thing I just want to ignore. Last but most important, I would like to acknowledge my academic and research collaborators, Choyon and Himadri from TCS. When I was working at TCS Research and Innovation, in particular, Choyon introduced me to this problem, and I have been grateful to that because this has led to many more fruitful collaboration, which I am still working. Haris, Ali, and Fahime from UNSW Sydney. Haris is a professor there with whom I started a long-term collaboration, and then working with his postdocs also on that. Brendan, he's our contact in the Defense Science and Technology Group, and the Australian Defense Force does a lot of work in that area. William from the university. Actually, I wrote both Sydney and Melbourne because when I started the collaboration, he was at the University of Sydney, but now he has moved to the University of Melbourne. With William, I pursue more of the theoretical aspects of this problem. So, and thank you for listening to my talk. If you have any questions, please feel free to ask me.
Thank you so much, sir, for this elaborative and very technically rich and informative talk. Like from the point of view of the application of robots in the real life applications. So the session is open for interaction, though it was throughout interactive session. But now as the session is at end, so participants can please unmute yourself and can ask if you have any query.
Hello, sir. Good afternoon.
Yes, good afternoon.
Yeah. So I don't know whether it's relevant to us or not. I wanted to know what is the progress of this particular domain so that that can be implemented. Small businesses like pharmacy business, someone is running a pharmacy business, whether that person can implement this kind of robot to find out the medicine from his or her medicine shop. Uh, So I wanted to know what is the progress so that it can be implemented the country like India inside a small shop, not the warehouses like Amazon or those companies are doing, but in a small businesses.
Okay, so let me tell you that implementing a multi-robot system is a complex problem. I mean, both from the not only from the research and engineering perspective, but also from the logistic and the supply chain perspective. And so for example, if it is a very small thing, so look, these problems are relevant because the scale of the things are large, right? If you have, for example, in a pharmacy, you have say 1,000 medicine, I think 1 or 2% can handle it, right? So I don't think first of all, it will be costly, right? So first of all, think of that. You have to install a set of robots, and then you have to program them in a way. Then you have to I don't know whether you can, probably you can use some off-shelf algorithm, but still you have to understand that, and these are because a lot of technical expertise to do that, right? Then you have to plan. So because it's a robot, you need a kind of you can say free area, right, where the robots can navigate, right? And if there are not enough much obstacle, right? Because if the robot hits into obstacles every now and then and trip, right? So then you have to have human operators. You have to always like hand holding the robots and pick them up, right? So you have to have clean passageways and things like that, right? So I don't think if it is a small instance, it is worth even deploying these kind of solutions, considering the cost and the complexity of thing. I mean, these things are truly does well when they are it's for the large instance of this, so that you have to scale it for that. I don't think for small instance with 500 or 1,000 items, these kind of things should be deployed. It's
Okay, sir, I understand.
Sorry?
Yeah, I understand that implementing these kind of things in a small business can increase the cost of the setup.
Yeah, it's not what the cost. I mean, because see, you want to do an economy of scale, right? So that's most important. Suppose I want to suppose, say for example, by selling each item, just an example, right? I am making a maybe 20% profit. So for example, suppose it's 100 rupees and then I get 120 rupees. I'm selling 20 rupees I am making. Now I have say 500 such thing. I'm talking on average, of course it will vary. So 20 into 500 will be like what, 10,000, right? So each robot may cost like 100,000 rupees or even more, right? Is it worth like to deploy such 5 such robot to manage this small utility where you will not get much money, right? So unless you are making, for example, say 1 million rupees.
So
Least,
that's
right?
why I was asking whether what is the progress of this kind of particular domain when it will become affordable to the small businesses like pharmacy. I mean, what is the progress that it can be implemented also in a small businesses? Let's suppose I want to open a pharmacy shop inside a airport where I don't want to put any person, only I will be there and I will get a prescription and immediately I can find out the medicine from my stack and I can hand it over to the person. So whether that can be possible within near future, like 5 years or 10 years.
So, the frank answer is I don't know. The kind of domains I have seen, for example, so first of all, let me answer. Most of these things are done in the developed countries, and maybe some of the big companies like in the supermarkets like Reliance or Flipkart, I think they are still experimenting with the fact. Okay, the publications also where I have seen that, like, I mean, there are many academic publications where they have just studied it from the mathematical perspective, right? Mostly the professors, but there are some professors and the researchers from Amazon, for example, or eBay. So they actually deployed that. So these, I think one of the main reason this research got a lot of impetus is because of Amazon, because Amazon was the one which they maintain hundreds of warehouses and large warehouses across all over the world, right? So they invested many of these the things in the technology, and many of them are proprietary also, right? So, but I have not seen much literature where they talk about this kind of applying this technology to small instances. So every technology has its you can say application area, right? I mean, you have to make it cost effective and scalable to do that. So not everything can be used everywhere. So for example, if some technology is available only for the smaller businesses, I mean, that is not scalable for deploying in a large scenario. Similarly, something which are cost effective when there is an economy of scale. So those things cannot be deployed in small scenario. So I don't know, maybe someday it's possible, but at this point, I don't know any of the, even in developed countries also, I don't see any pharmacy or those kind of things they would be able to afford that.
Okay, sir. Thank you. Thank you so much.
Thank you. Any other questions? Sorry, Shondeep, I am keeping you waiting. Sorry about
No,
that.
not at all. Absolutely fine.
So if there is not any query for now, we can share email ID of our speaker, Dr. Arindam Pal, with the participants, and they can have offline interaction with the speaker on their related topic. So, sir, can we conclude the session here?
Okay. So is the Shondeep's talk after me?
Yes, yes.
Oh, I thought that he was supposed to give it yesterday.
No. Today,
Oh,
sir.
It was on Saturday, yeah.
oh, okay. Because in the schedule I saw, I think the schedule must have changed later, right?
No. In schedule, it is
Oh,
same,
okay.
sir.
Okay, no problem. It is already 10:46 in my PM in my thing. So maybe I'll
Yeah.
listen a little bit to Shondeep's talk and then go to sleep. Okay, thank you. I'm unsharing my screen, and Shondeep, please go ahead and share your screen. Thank you, and thanks a lot to all the like attendees for patiently listening to my talk. And thank you also Suparna and Shoel for inviting me. I really appreciate it.
Thank you so much, and we extend our heartfelt thanks to you on behalf of the organizing committee. So with this, we are moving forward to our final session of day 6 of our FDP. We welcome you, Dr. Shondeep Chakraborty, sir, in the FDP program. And good evening.
Thank you. Good evening.
Yeah, so with a brief introduction, the session will be over to you. Dr. Shondeep Chakraborty is working as an associate professor in the Department of Computer Science and Engineering at the Indian Institute of Technology, Kharagpur, and leading the Ubiquitous Network Systems Lab, UBNet. The URL is ubneticietkgp.github.io/ubinet. He obtained his bachelor's degree from Jadavpur University, Kolkata in 2009 and MTech and PhD both from IIT Guwahati in 2011 and 2014 respectively. The primary research interests of Dr. Chakraborty are distributed systems, pervasive ubiquitous and edge computing, and human-computer interactions. He received various awards including the Google Academic Research Award, GARA to 2024, Google Award for Inclusion Research on Societal Computing 2023, Indian National Academy of Engineering INAE Young Engineers Award in 2019, and the Honorable Mention Award in IEEE MDM 2022, ACM SIG CHI EISC 2020. Dr. Chakraborty is one of the founding chairs of ACM iMobile, the ACM SIG Mobile chapter in India. He is working as an area editor of IEEE Transactions on Services Computing, Elsevier Ad Hoc Networks Journal, and Elsevier Pervasive and Mobile Computing journals. Further details about his works and publications can be obtained from his webpage, that is cac.iitkgp.ac.in/sandeepbc/index.html, and that will be shared with the participants as well for further reference. So with this, the session is over to you, sir.
Thank you. Thanks, Suparnadi, for this introduction, and thanks, Suparnadi and Sohail, for inviting me to deliver this talk during this faculty development program. So this particular talk is highlighted towards an application of artificial intelligence and machine learning for healthcare domain, particularly our experience in working on such a project for the past 6 or 7 years, I would say. So, okay, so it is already in the afternoon, and I guess that you had heard several talks in the past few days, and this is the last talk of this session. So you must be waiting for ending of this session and get released. So I will not make you bored a lot with a lot of different technical stuffs and different terminologies, different mathematics, and so on. I will try to keep my talk short, well within the time, as well as more of a kind of story about how we build up the things and what was our experience in building up such a solution, a practical solution that we also tried to develop. And it is actually an ongoing project. We are not yet fully successful. I will also try to highlight kind of our story behind the success that we have seen, and I would say the failures that we also experienced. So that way, hopefully it will give you an idea that what are the hurdles or what are the kind of roadblocks that we can face if we take up such kind of AI-based solution for a practical problem and try to deploy it. So without wasting much time on the basic introduction, let me go to the topic, go to the insight of the topic. But before that, while I will carry forward my talk, please feel free to stop me if you have any doubt, if you want to get further clarification, or if you think that some statement that I have made is not correct, or you have some different opinion on that. So please feel free to stop me, and we will have, I will love to have a discussion. So there is no hurry that I have to finish the entire thing, all the slides that I have prepared for this talk. So it would be better if we can make this talk more interactive, and we can also try to figure out if we can think about some concept of some idea that possibly we can work upon in the future. So as this particular talk, as I was saying, that we are talking about this healthcare domain and use of artificial intelligence for the healthcare domain. So the use case that we are targeting for is something called Alzheimer's disease. So if you have not heard about it, what is Alzheimer's? It is kind of a neurodegenerative disorder. We sometimes call it as dementia. Although dementia is not exactly similar as Alzheimer's. So Alzheimer's is basically a stage of dementia. There are different stages of dementia that may come up. Now, with this Alzheimer disease, typically the older people, they experience this. People, their cognitive ability, they get declined with time. They get trouble with mobility. They get confused. They get memory loss, tremor, poor judgmental ability, and so on. And this Alzheimer's, which is a type of dementia, as I was mentioning, it is actually a progressive neurodegenerative disorder, and these instances of Alzheimer's are increasing significantly across the older population in various countries in the world. So, as I was mentioning, that it is a progressive neurological disorder where people face problems with language, orientation, mood swing, loss of motivation, self-neglect, behavioral issues, such kind of things keeps on coming. And approximately, so this is a 2020 statistics. So some statistics when we collected as we are working on this project. So approximately 50 million people worldwide, they are suffering for Alzheimer's. And if we just try to contrast it with respect to COVID, because this 2020, 2021, we are observing the surge in COVID. So the reported death from COVID was approximately 6.7 million or something like, if I think about the current statistics, it is 7.5 million. Much less compared to what people suffer from Alzheimer's. And such kind of diseases are more severe among older people when the age is more than 65 years. Statistically, females are more affected. Often they are withdrawn from their family and society. Their bodily functionals are lost, ultimately leading to death. And typical life expectancy following the diagnosis is 3 to 9 years. That means the person suffer a death within 3 to 9 years once they get diagnosed with Alzheimer's. Here is some statistics across. So the first curve, it shows you kind of country-wise prevalence of dementia. So you see that China is in the first, then US, and the third in the world is currently in India. And statistically, it is similar to US. Then Japan, Brazil, Germany, and many other countries. And over time, it is increasing significantly. So it is predicted that by 2050, 90 million people worldwide will suffer from dementia. Now, there are various stages of dementia or Alzheimer's disease, like we call it early cognitive impairment, ECI, mild cognitive impairment, moderate cognitive impairment, and then severe cognitive impairment. Now, typically, so this is basically our experience. So later on, I will put up more light on this, that this particular project, we started it along with University of Maryland at Baltimore County in USA, UMBC. So UMBC, University of Maryland, they have a nursing school, and as a part of that nursing school, they have a rehabilitation center where they put up the dementia people. So initially we talked with the doctors at that UMBC nursing school, and later on around 2020, 2021, we started collaborating with AIIMS Jodhpur along with IIT Jodhpur. And there we also talked about several doctors at AIIMS Jodhpur, because AIIMS Jodhpur has a neurological center, and they also maintain a rehabilitation center for these older adults who are suffering from dementia. So we talked with those doctors, and the immediate feedback that we get is that majority of the patient that they treat, they come at a significant stage of dementia. That means when they are, so approximately 90% of the patient, they come when they are suffering from severe cognitive impairment, and rest other comes when they have moderate cognitive impairments. They hardly get any patient who are at the early stages of dementia, or they have the mild cognitive impairment. And the particular reason for this is that, see, these cognitive impairments or this kind of neurodegenerative disorder, if you just think about, try to relate it to the older people who are there in your family, you will see that it is very common for the older people to forget something. Okay, and they may make some mistakes. They forget names of the people. They forget to do some tasks. They easily get lost into certain thoughts. And in our society, we take them as a common. We think that, okay, the older persons are likely to forget the names of the others, or they're likely to forget their task. Okay, so that way, when persons are suffering from this early cognitive impairment or mild cognitive impairment, the symptoms are very common, or the symptoms are kind of very generic across the community, and we take it, okay, it is normal. We are not been able to directly differentiate that whether those kind of symptoms are due to their age, or it is due to that they are slowly getting these symptoms of dementia. So because of that reason, at the early stages of dementia, it is very difficult to understand, or very difficult to pick up those specific cases and take those people to the doctor. Most of the time, when they start suffering from the severe stages of dementia, at that point of time, we detect it. We understand that, okay, now something is wrong with the person, and we take them to the doctor. But the challenge here is that if we think about the typical treatment that are there for dementia is monitoring and changing in the lifestyle, okay, at the early stages. So Alzheimer doesn't have any medicine. You cannot have any medicine or anything to cure it. It progress if a person gets attacked by dementia or Alzheimer, it is a progressive disorder. It will progress over time. So what you can do, that by monitoring or by changing in the lifestyle, you can reduce the rate of progress. So if a person get a transition from, say, mild to severe in 6 months, you can possibly make it to 6 years or 10 years by making a change in their lifestyle, by making certain kind of habitual changes. And that is the reason that it is very, very important to bring them to the doctor at the early stages. Well, and which we typically are not been able to do. And the doctor says that if they can get those dementia patients at their early stages, they can still do something, at least by monitoring their progress, monitoring or changing their lifestyle, making them through some common practices. They can possibly reduce the progress of dementia. They can increase their life expectancy. But most of the time, as I said, that more than 90% of the cases, they already get the patients when they are at a severe stage. And most of the time, the person face a death within 1 year or 2 years. Now, our objective in this particular work was that whether we can use pervasive sensing modalities that develop something to monitor the activities of the individuals for detect this early cognitive impairment and mild cognitive impairment. So detect the dementia at their early stages. And also remember that there is no such kind of direct test to detect Alzheimer's or dementia. The doctors also rely on certain kind of secondary scrutiny, like monitoring that, say, if a person is forgetting something, then what type of forget is happening. So typically, I can give you some clues, some hints that what is the nature of forget that people faces when they are in dementia. So, for example, whenever people comb their hair, okay, so in general, a normal people, say, if they regularly comb their hair from left to right, a dementia people, what will happen that suddenly for a day, they will possibly comb from right to left. So the direction of the combing will get changed. Okay. So this kind of forget they will face. Okay. So it is not like that they will simply forget the name of someone or simply forget. So you have asked them to bring sweets from the shop. They will go there and then start talking with their friends at some club and then forget to bring the sweet home. So this might be natural, but the changes in the activity pattern in this way that they are combing their head from left to right, but suddenly in one day they come from right to left, or say when latching the shoe, they latch the left shoe but forgot to latch the right shoe. So these are the specific symptoms of dementia. Okay, so now in an activity pattern, what we will observe that they will forget a part of the work. So in the same nature of the work, like latching a shoe or combing hair, well, they will forget a part of it. Well, so these specific cues give you the idea that, well, the person might suffering from dementia. And these are very important. And as you can observe that you are not going to observe such kind of cues daily at every instances. They are actually rare instances in practice. Maybe once in a week, they will just suddenly change the way they comb the hair, or suddenly in one day, they will forget latching their left shoe or right shoe, whereas latches the other shoe. Okay, so this kind of sudden things will happen. And that's why continuous monitoring of the activity is important. And we thought of that whether we can come up with certain solution through which we will be able to monitor these people continuously. And if there is such kind of instances, which gives an idea that, okay, the person might have symptoms of dementia or might have symptoms of cognitive impairment, then we can take them to the doctors for further detailed check. Now, as I was telling that if we look into the standard activities that we perform our day-to-day life, the activities that we perform, we classify it into multiple groups. Okay, so some set of activities, they are called the activities of daily living or ADL. Well, and there are specifically 5 types of ADLs. One is eating, taking bath, changing your clothes, walking or any kind of mobility, and cleaning yourself. That is going toilet and so on. Okay. Now, typically during ADL, or there are another class of activities which are called the instrumental activities of daily lives. Instrumental activities of daily lives are like taking pills, say going for shopping, cleaning home, talking to others, paying the bills, driving. Okay, these are called the instrumental activities of daily living. And typically for a dementia patient, what we are going to observe that during their ADLs, like activity of daily living and instrumental activity of daily living, we can observe certain kind of these mild changes or sudden changes. Well, so for example, the person is likely to take the pills. Well, so the person has 10 pills that they need to take at night. Say they took 9 of them and have not took once. Okay, so this can be a symptom of dementia. Well, or say for example, they are going for shopping. Okay, and you ask them to bring 10 different instances. Okay, or something, the example that I was giving, that you asked the person to bring sweet, and the person went to the market but forgot to bring sweet. Okay, whereas the primary objective was to bring sweet. Okay, so these are in the context of IADL. So IADLs are again, sometimes they are a little bit confusing about identifying the dementia instances. But ADLs that I was talking earlier, the ADLs are much more prevalent in identifying such kind of dementia instances. For example, you are supposed to taking bath, you have sent the person to take bath, the person went inside the bathroom but forgot to wash themselves. Okay, so that can be a symptom of dementia. Well, so that way we can identify that when there is a deviation from their activity pattern, which can possibly be identified as dementia. Okay. Now, the daily activities that we have several type of simple activities as well as complex activities. And the idea here that from these activities, whether we can instantiate or whether we can extract such kind of instances which are symptoms of early stages of dementia. So on this slide, this was one of our research paper that came up in IEEE PARCOM 2023. We developed an approach for this early assessment of cognitive and functional impairments from the accelerometer data. I'll tell you that the final system that we built up and how we came up with the solution. And this is a work that was with UMBC, University of Maryland at Baltimore County. As I was mentioning at the beginning of my talk with my colleagues there, Arjo and Nirmallo. And we also collaborated with Dr. Elizabeth Galik. Dr. Galik was a neurologist who was working at this UMBC nursing school. And our students, Srini and Shomojit, who worked on this project. And this was a project that was actually funded by NSF Career Award and US Army grant at the US side, and MHRD as well as DSTTIH grant from ISI Kolkata at the India side. And both of the team, we got an award, a grant from Alzheimer's Association to develop this particular solution and deploy it in US as well as in India, and to see that how it works. So the idea here is that, as I was mentioning, that to look into the activity patterns of the individual, and from the activity patterns to identify whether we can see some symptoms of dementia. Now, these activity patterns and understanding the activity patterns from different kind of sensory devices like a smart band, smartphone, they are well studied. I think many of you have seen several such work, and there are nowadays we have there these smart bands like Fitbit and the smartwatches. They can continuously track the type of activities that we are doing. So there are this fitness tracking application, the fall detection application, sports analytics application, okay, dance activity recognition. There are multiple such applications which are already available and already deployed. Okay, and the basic idea there is that you take the accelerometer reading. Say, for example, you have a smart band like a Fitbit. From that smart band, you take the accelerometer reading. From this accelerometer reading, you identify different body gestures. Like, say, for example, what is the pattern in which I am moving my hand? Well, and then you map these gestures to the activity signatures. Okay, that means whenever I'm going to run, I will have a sequence of gestures, or say, for example, the different type of ATLs that I was talking about. That say, when I am brushing my teeth, at that point of time, I will have a gesture like this. When I'm eating, I will have a gesture like this. So that way you monitor the gesture pattern over time, and from there you figure out the activity signature. And people have used different kind of machine learning, deep learning algorithms to identify such activity signatures. Well, now there are few observations that we had. So as I have said that it is not like that we suddenly started this project. We actually did a long survey, and that survey was for nearly 2 years in 2018, 2019, with several doctors, neurologists, as well as dementia patients. We had interviewed their caregivers, okay, the persons from their home, to understand that what typical behavioral and functional changes are there in those dementia patients, and how those changes have developed over time. Okay, so what we observe that any kind of cognitive impairment, that means whenever they have cognitively declining their ability, that is characterized by certain kind of functional and behavioral changes. Okay, now what is meant by functional changes? Functional changes means they will have less energy in doing certain kind of work. Well, so you will see that they are looking very lazy over time. They are not active in doing certain kind of works. And also there would be behavioral changes. Behavioral changes means how they are approaching with you. Like whenever they are talking with you, you will see that you are talking with that person for continuously, but the person is not responding. Although that same person used to respond very frequently in the early days. So you are calling that person, the person is just picking up the phone, just saying hi, hello, and cutting out the phone. So such kind of behavioral changes are being observed. Okay, and typically in the doctor side, as I was mentioning, that the doctors identify such kind of instances of dementia through several clinical assessment or several rounds of clinical assessments. Well, and there are no direct tests through which you can identify this dementia or the symptoms of dementia. Well, so there are various neurological examination, there are various type of physical examination and laboratory tests. Well, there are experimental imaging studies, there are cognitive status tests, mental cognitive status tests. Well, and that way, the person need to make a visit to the hospital multiple times. There are long waiting times. Sometimes it is expensive, those kind of tests. And most importantly, many of these tests are experimental tests. So, say for example, you take the MRI scan, and from MRI scan, you try to find out whether there is any kind of changes in your nervous system which can possibly lead to Alzheimer's. But there is no science or no medical instances which says that, okay, if this is the MRI pattern, that will have certain surety that the person has Alzheimer's. Well, and as I was telling, that there are a lot of benefits of early diagnosis, that you will get more time to investigate. Well, so and dementia can also occur due to various underlying diseases or reasons. And if you can diagnose it early, then you will have a wide treatment option. You can go through various type of clinical trials, adapting to the lifestyle changes. Well, you can get emotional support. Emotional support is very important for the dementia patient. That actually reduces the progression of dementia over time. Well, so that way it can also kind of reduce cost of medicine cost and so on. So the idea here was that if we can do the early diagnosis using such kind of activity recognition patterns, well, so you enable passive health assessment through certain smart bands, and we thought of that, okay, nowadays these smart bands are very common. We have this Fitbit, different kind of smartwatches, different kind of fitness bands that people are anyway using. So can we kind of extract data from there to understand such methods? And importantly, these bands are very inexpensive. Also, if you think about a smart band with an accelerometer, if you go to the market, you will see that you can possibly buy such a smart band with 2,000 rupees. Well, so that way it will reduce cost and also kind of promote hospital visit before it becomes too late. So the broad objective that we have is to enable early assessment of such kind of functional and cognitive health impairments through individuals' daily activities that we capture through the accelerometer data of a smart band. So there are several such work on the health assessment. So if you look into the literature, it is not like that we are the first one who are doing this. There are a lot of works which have tried to look into various type of methods and models to identify this kind of cognitive declining in individuals, the symptoms of dementia, and so on. But the thing is that the solution that we are trying to build up, it is going to be a kind of end-to-end pipeline, right? So that's where we differ, that we are going to implement the model, going to put up the model on the device itself, and our objective was to deploy it with the actual dementia patient in AIIMS Jodhpur as well as in UMBC Nursing School to see that how it works. So this practicality comes here, which becomes more important. Now let us see that what kind of challenges that we face, or rather we faced when we tried to think of a solution or building up a model to solve this problem. So I hope that by this time the problem is clear to all of you. Our problem was that we are getting accelerometer data. From that accelerometer data, we have to identify various kind of hand gestures and then map this hand gesture to the specific activity pattern. And our objective was that if we monitor the activity patterns over time, then whether we can see such kind of sudden changes in the activity pattern, which can give an indication that the person is possibly having certain kind of cognitive impairment. Now, the thing is that I'm not sure whether some of you have already worked on such kind of data set. You will see that most of the work that we have in the literature that have been done in the academic setup, people got some data for specific activities. So something like that. You ask the people that, okay, you do these 5 activities: running, walking, climbing upstairs, climbing downstairs, remain static. So you perform these 5 activities, and for each of the activities, you get the accelerometer data from the smart band, then apply it to a machine learning classifier to do the classification. So most of the works are like that, and they work good. They give very good accuracy. But the moment you will take it out of the lab and try to deploy it on a device which is going to do continuous activity recognition, it is not only that you have just 5 activities that you are trying to recognize, rather you are going to recognize all possible activities that a person is doing over time. From the time the person is getting up from the bed and then going to sleep, you are going to monitor them continuously even during the sleep. Then it becomes much more challenging. Okay, so if you increase this number of activities, say from 4 activities to 8 activities to 14 activities, as you can see in this graph, the signatures, they get overlapped. Okay, so say for example, for 4 activities, we can see that, okay, we still have certain separability in the data, but as we go for 8 activities, that separability get reduced. If I go for 14 activities, the separability get reduced even further. Okay, so no machine learning classifier will be able to separate them out properly. And interestingly, there are a lot of motion artifacts which are similar across activities. So for example, whenever I'm eating, I'm just raising my hand to mouth. Okay, so this kind of gestures I'm performing. If I'm taking a bath, that is also same kind of gesture. I'm taking the water in a mug and putting it on my hand. Only difference is that for eating, I am putting it up till mouth. On taking a bath, I am putting it up till my head. Okay, so that kind of minor differences are there, and that way there are kind of lot of overlaps across the gesture signatures that we get. Well, so this kind of marginal separability of data becomes a huge challenge if we try to implement such existing models, the machine learning models, to do the activity classification for a real world data. Well, when you are not handcrafting the features or handcrafting the data, rather you are just getting the naturalistic data and trying to apply certain kind of classifiers on top of that. Another problem comes in terms of model training, which is due to this, what we call as the imbalanced data set. Now, if you think about that, okay, if you take for say 30 days, take data for 30 days, then a person takes meal how many times? So 2 primary meal and at least 1 more breakfast kind of meal, then maybe sometime in the afternoon, so at least 3 to 4 meals per day, right? But if you take the activity of brushing, that is only once per day. Right? If you take an activity, say going to market, okay, so that is very occasional. It might be like twice a week the person goes to market. Right? So that way, for the different type of activities that we observe, different activities are done in different frequency, and in your data set that you are going to collect, it is going to be significantly imbalanced or highly imbalanced. Well, now with an imbalanced data set, training a machine learning model, particularly a supervised model, is significantly challenging because this class imbalance problem, although there are approaches in the literature like you can apply different type of method to generate the class balancing, but those methods actually work up to certain limit, up to certain level. And when you get such significant class imbalance that, as you can see from this graph, this actually shows the instances or the percentage distribution of the data for, I think, 16 activities or even more than that. Yes, 16 activities over time. Okay. And those data have been collected for a month, and how much imbalance we have in that data set across those 16 activities. Okay, and that can lead to a biased model, which we need to avoid. So by considering these two major challenges, one was this marginal separability of the data. The second challenge was about this imbalanced data set. We tried to build up this method, on-device method for identifying these functional and behavioral impairments. We call this method as COGX. Now, this is the kind of broad pipeline. I will go to the details of each of these approaches, that what was our motivation behind using that and how we take it up further in our application. So the first step was to get the data. So we got the data, like the accelerometer data, from a wearable device, from a smart band. We can use any kind of commercial smart band available, but because we also needed the ground truth data, we used the medical grade smart band called Empatica. I will talk about it later. Then we had two different type of learning framework. One we call as the contrastive learning. So this contrastive learning was helpful to address the issue of marginal separability in the data. I will talk about contrastive learning in much more details. And then we had something called the multitask learning. Okay. And the idea of applying multitask learning was that here you see, as I have said, that a dementia patient can have cognitive declination, issues with the cognitive behavior, as well as they can have issues in the functional behavior. Okay. And particularly, we are going to utilize the changes in the functional behavior to identify whether they have a cognitive impairment or not. Well, so that's why our objective was to identify the activity pattern. But while doing the activity pattern, we are also trying to find out whether the person has dementia or the person do not have any dementia. Okay, so that way we have two different set of tasks. One task was to do the kind of activity classification from the gesture pattern. That was the kind of primary task that we had, which could give the activity level correspond to the accelerometer data. And the second task was, while doing this classification, to identify that whether the person has any symptoms of dementia, which can give me the functional or the cognitive health levels. Well, and from there, finally, we have used a very interesting method of developing a metric called impairment indicator. I'm going to talk about later that what does it mean, which actually finally tell me that the kind of anomalies or kind of behavioral changes that we observe by continuously monitoring the activity pattern, whether that was due to dementia or not, whether that was just because the person was having old age, their functional abilities getting reduced. Is it because of that? Or is it because of the person is suffering from the early stages of dementia? Okay. Now, let me move to this idea of contrastive learning. Well, so I'll talk about a little bit of background here, that what was the notion and why we thought of applying contrastive learning framework for this particular problem. So as I was mentioning, that the basic idea of activity recognition is that you look into the gesture pattern over time, and from that gesture pattern over time, you derive that what is the activity level. Say, for example, in this case, you have different type of gestures that are happening over time. And if you can keep on monitoring this gesture over time, you can say that, well, the person is cooking, or the person is, say, cooking omelette kind of activities. Okay. Now the thing is that for identifying the activity, if we think about that, okay, we are going to build up a machine learning level, the first stage can be that, well, we can use the various type of handcrafted statistical features from the gesture signatures. Like we can take the mean, median, mode, kurtosis, this kind of parameters, and then train a classical ML model to do this activity classification. Okay. But the problem is that this kind of features need to be extracted and engineered properly. Well, now this activity classification problem have been well studied in the vision domain, where you have a camera, and from the camera data you are kind of identifying whether a person, what type of activity the person is doing. But we have a fundamental difference the way we do image or video processing and we do this physical sensor data processing. The thing is that if you have a visual data, okay, from a visual data, identifying the gesture is more prominent. Okay, someone can look into that, find out that, okay, this is the particular features that I am observing. And from there, I can say that, okay, this feature I can take to train my model. Well, but if you look into the sensor data, so for example, if I just give you the raw acceleration data, from the raw acceleration data, it is very difficult for you to understand that what is the feature. You just see certain kind of up and down in the signal pattern over time. Okay, so how you are going to find out that what is happening there or what type of features can be extracted from that data. Okay, so extracting or understanding the statistical features and their importance from the physical sensing data is much more challenging compared to the visual data. Well, so another question comes that in the vision domain, computer vision domain, there have been different models that have already been identified or already been developed. Well, so the question is that can I use those vision models for human activity recognition? So, for example, I take the image representation of the accelerometer data and pass it to a vision-based model for activity classification. What would be the problem in that case? Now, the thing is that if you think about the accelerometer data, the question is that at what granularity you are going to visualize it. So here in the graph, I have shown two samples, right? You can look the accelerometer data at a kind of much more coarse level, or even you can take a sample of it and look into it in a much more finer detail. So it depends on that what is going to be your window size. At what window size you are going to process your accelerometer data and you are going to visualize it data. Okay, again, that raises another challenges for building up the supervised model. Well, now the thing is that if you are going to use such kind of supervised model, well, so there are lot of different works, different data sets which are available, which provide raw time series data, and then, as I was saying, corresponds to different activities. You can take that data, you can train a supervised model. Well, so for example, in literature, people have utilized this one-dimensional CNN for predicting the feature classes, where you give the three-dimensional representation of the accelerometer and the gyroscope data, and you make small window for training, means the input. And finally, the model is going to do a multi-class classification, finding out that in which classes that data belongs to. Well, but the thing is that to train such kind of model, you need a significant amount of level data. And now you think of that the situation that we had, that a person is wearing a smartwatch or a smart band, from where we are going to get the accelerometer data, and that data is collected over the entire day, and the person is doing different type of activities at different patterns. So who is going to generate the label data corresponding to those activity classes? Okay, as you can understand that getting that label data is not easy at all, or rather in other words, I will say that it is not feasible at all. Okay, so we move to the idea of self-supervised learning. Okay, so what is the broad idea of self-supervised learning? That a self-supervised learning method typically does not rely on label data set or any kind of supervisory signals. Also, it generates implicit labels from the unstructured data. So, for example, I had certain kind of pretext task. Well, pretext task is say cycling. I have cooking. I have running. Okay, so those are the pretext tasks for which I have taken a small amount of data and I generate some intermediate representation of that data set. Well, and now my classifier, it is going to see that the activity signatures that I'm getting, whether that activity signature has similarity to any of these intermediate representation or not. Okay, so if there is an intermediate, there is a similarity with that intermediate representation, then they label that data point with the corresponding class label. Okay, so for example, here I have a different way of doing the cooking. Now, if you find out the distance of this data from this cycling and running, that distance will be much higher. With this cooking activity, that will be lower. So this data point will be labeled as cooking, and that will be part of my new data set that will be used to kind of train or doing the inference on your model further. Okay. Now, this contrastive learning framework that I was mentioning earlier, this contrastive learning framework is one such way of doing the self-supervised learning. So the idea here is that you pick up an anchor, okay? And this anchor is the target that you want to learn. Now, you generate a set of positive samples. The positive samples are the samples which are similar to the anchor. Well, similar means they have similar kind of semantic meaning. Well, and a set of negative samples. Okay, so the samples which are different from the anchor. So I'm going to give you an example that exactly how it works. Well, and then you develop an optimization function, and the target of that optimization function is that it will pull the anchor and the positive embeddings closer and push the anchor and the negative embeddings further. What does it mean? So here is an example. Say you want to identify the activity cooking. Okay. So you take one instances of cooking, okay, any instances of cooking, and use it as a pivot. Okay. Now you get different such variations in cooking, okay, which are your positive samples, and all other activities apart from cooking, all other activity labels that you have, cycling, running, driving, okay, any other activity labels, they are working as the negative. Now, what your this encoder is going to do, the encoder that we have in my contrastive learning framework, they are going to pull the positive samples closer to the anchor. So that means they are going to minimize the distance between the anchor and the positive sample, and they are going to maximize the distance between the anchor and the negative samples. Okay, so that means if you look into, if you think about this, the problem that I was talking about when I discussed this marginal separability of data at that point of time, my data points are mixed, out of which I pick up the anchor and the positive instances. And then if I apply this encoding mechanism, what the encoding mechanism is going to do, it is going to pull the similar type of instances close to each other and dissimilar type of instances further to each other. So that means after the training, I generate an embedding space, and in that embedding space, all the yellow dots, they are closer to each other. All the blue dots, they are closer to each other. All the green dots, they are closer to each other, and so on. Okay? Because the positive pairs, they are kind of pulled together, they came together. Okay? So we tried to minimize the distance between them. And the negative pairs, they went far from each other because we tried to maximize the distance from them. Okay? So that way, this learning framework is actually determining that how much minimization I have to do or how much maximization I have to do to bring separability in the data. Originally, the data was not that separable, but once it went through this encoding process, they becomes separable. And I can have different type of loss functions for this optimization. One particular loss function that is widely used in the literature, it is called the triplet loss. So what the triplet loss does, that it takes the anchor x along with the positive sample x plus and negative samples x minus, and it tries to maximize the distances in such a way so that the distance between the anchor and the positive, that means fx minus fx plus, that get minimized, whereas the distance from the anchor to the negative, that means fx minus, that gets maximized. Okay, and there are also various other loss functions which are available. You can go through that, like there is called lifted structure loss, NPR loss, NC, and various other variations which are available. Now the question comes, as I have said, that labeling data is challenging. I cannot get the labels all the times. Well, so the question is that how I am going to generate this labeling, and that is the most important part in this contrastive learning framework, that with minimal amount of labeling, how I can still train a model. So the idea here is that for the positive sample, you pick up a few anchors and then apply augmentation there. Okay, and the negative sample is everything else in your data set. Well, so for example, if I apply this contrastive learning framework in the image domain, actually it was initially popular in the image domain, your augmentation is easy. So for example, you want to separate out cat from all other animal. What you do, you take 4 samples of cat, image of cat, and then apply different type of image augmentation technique like flip, rotate, color distortion, random crop, zooming, blur, whatever image processing technique that you can apply, and you can generate a large set of positive samples. Okay, and everything else that you have, they are the kind of negative samples for you. Well, and so from there are different kind of framework which have been applied for this contrastive learning. One popular framework is this SimCLR framework. Well, the SimCLR framework works in this principle of this augmentation principle. So for example, for the positive sample, you apply augmentation to generate multiple such positive samples. Well, you apply a CNN to get their representation. And after you get the representation, then you apply a MLP framework to kind of reduce the distance between the positive samples and increase the distance between the positive and the negative samples. So that way it works. And it have been very popular in the image domain. But the question for us is that, well, for the image domain, doing this data augmentation is easy. But how do we apply data augmentation for the physical sensing data? Okay. Now, the basic idea is that you apply the law of physics. Okay. So, for example, on accelerometer data, what type of method that you can apply for doing that augmentation? And there have been several works in the literature. I have given the kind of barcode here, which you can scan and you can find out. There are different works that have talked about that how you can augment such kind of physical sensing data. So we applied that method, and then we used this contrastive learning framework to handle this issue of marginal separability of data that I talked earlier. Okay. Now the next part was to do this multitask learning that I also mentioned, that our primary task was to identify various type of activity patterns. And while doing this activity pattern classification, in turn, my purpose was to identify whether the person is suffering from certain kind of neurodegenerative disorder like dementia. Okay. So what we do, that we apply this contrastive learning framework on top of this multitask learning. I have this primary task. The primary task was to identify the various type of activities from the data. And I had the auxiliary task. The auxiliary task was to identify whether the person had mild cognitive impairment or not. or what type of cognitive impairment level the person has, and accordingly we build up the framework. Okay, so I'm not going to this kind of mathematical details about what type of actual loss function or the model parameters that we set. If you go to the paper, you can look into that. So let me just talk about from there how we actually identify dementia. Now, as I was telling you, like for the dementia people, what is going to happen? That suddenly we'll see certain kind of changes. Say the person was doing brushing from left to right in day one, day two left to right. So that way they typically do brushing on left to right. But only on a sudden day, they suddenly did the brushing from right to left. Okay, which is a kind of pattern change, sudden pattern change. And these sudden pattern changes are actually the indication of dementia. Well, so if you think about from the modeling perspective, this is actually result in an error in the modeling, because my model is going to look into a specific pattern over time, and they will suddenly observe that there is a deviation from this pattern. Okay, and the question is that how I am going to identify such kind of deviation in the pattern. Well, so, and also I need to understand that whether this deviation in the pattern,
Chat box.
whether it is a symptom of MCI or something else. Okay, so any query?
Yes, sir.
Yeah.
Like asking that how do you know or detect MAC? In the chat box, Mr. Rambaran Singh has asked that how do you know or detect MAC?
I'll come to that point.
Okay, sir.
I'll talk about it. Okay. So, yeah. So, what we do, we develop this metric called impairment indicator. What is this impairment indicator? The impairment indicator is that we find out that while I am doing this classification task, during this classification task, when my model is not been able to classify. Okay. Now remember that this is not a supervised model. Okay. So we are doing a semi-supervised learning. Okay. Or self-supervised learning. Now in this case, I had this anchor element, and then I'm trying to find out whether my parameters or other points, data points which are there, they are similar to the anchor or they are dissimilar from the anchor. Okay. Now the thing is that if your model suddenly observes that for certain data points it is not been able to do this classification task, that means with respect to certain features it is similar to anchor, with respect to certain other features it is dissimilar to anchor. So those are the cases which are possibly the anomalies. Okay, so they are possibly the instances where which your models are looking for the first time. Well, and these are the instances which are important for us. Well, so that instances we actually identify from this cognitive impairment. And the question that you are asking, that how we find out the MAC, MAC is not a metric which is of interest to us, because as I have mentioned that we are not going to do a perfect classification here. Well, so the classification was our primary task. Well, but I train my model so that it can classify. But ultimately, my objective was not to classify the activity instances, but while classifying the activity instances, to find out whether there are certain instances where there is a sudden changes in the pattern. Okay, those changes we are catching through this impairment indicator metric. Okay, which is a kind of new metric that we have introduced for this kind of problems. So now let us quickly go through, because I'm also kind of moving towards the end time. So let me quickly go through like what type of observations did we have and the way we did the experiments. And as I have said that we primarily had two objectives. The first objective was to do the functional impairment assessment, where I have different type of activity levels. And the secondary task or objective 2 was to do the cognitive impairment assessment, where I have various kind of activities, and from there I am going to assess the dementia status. So we have taken this wearable device, the Empatica E4, which is a kind of medical grade device. It provides the accelerometer data, but along with that, it also provides many other medical parameters like heart rate, ETA, and various other things. We worked with the accelerometer data. And for the ground truth information, we used the survey-based assessment, the clinical assessment, the typical clinical assessments that the doctors do. So there are three different assessments that we have applied. One is called the SLUMS examination, which is a screening method for dementia. The Bartle scale. Bartle scale is a functional performance measure for activity of daily livings, and Lawton instrumental activities of daily living examination, which is an examination for the IATLs. And then with this ethical approval, we conducted this experiment in the hospitals. We had 25 older adults who are residing at a continuing care retirement community. Age was more than 65 years. And many of them had symptoms of dementia or underlying neurodegenerative disorders. So we applied this classification task there. And as you can see that we identify various type of activities that can give us the signature for dementia. And based on that, we tried to train our classification model, and various type of model parameters that we have set up. I'm not going to the details due to this timing constraint, but let us try to look into the results. So I'll rather than the exact accuracy results or how the loss function behaves, let me just show you how this visualization of the data happens after we apply this contrastive learning framework. So this A and B, they are for the functional classes, that means the various activity classes, and C and D was for the cognitive impairment assessment. Okay, so what you can see here that after we have applied this kind of contrastive learning framework, the data becomes separable. So different colors actually shows different classes, right? So this contrastive learning framework that helped us to bring this separability in the data, in the real-time data, on top of which we applied this anomaly detection for, or anomaly identification for this impairment indicator identification. Well, and this is something like when we define for different type of activity clusters, how they look like. And as we see that various kind of clusters, if we look into their PDF, their patterns are kind of quite similar in the actual ground truth level and the inferred activity level after applying this contrastive learning framework. Okay, and I'll skip this detailed analysis due to the interest of time. So what we actually finally observed is hypothesis testing actually tells me that how well we are being able to identify the dementia instances at different level. There are three dementia stages: the normal, MCI, and dementia. Okay, and on other hand, I have the different activity level and their corresponding activity scores. As you can see that these individual cases, my that Kendall's tau coefficient, which gives me the output for the hypothesis testing, it was quite high. Okay, and they actually tells me that okay, I can identify these instances with quite high accuracy. So you can see that for various classes, like the dementia classes, it was 0.97, and for the normal classes, it was 0.98. For MCI, it was 0.85. So with very high accuracy as well as robustness, we can identify the actual dementia levels. So coming to the limitations that we actually encountered while working on this area. So what we see that, well, this impairment indicator that gives us a very interesting insight out of it, but there have been several interesting observations that we had. So as I said that initially this work was done in collaboration with UMBC. We deployed the model at UMBC. And after deploying this model at UMBC, we trained the model, we tested it, and the results that I have just shown to you, we see that it works very good in those instances. But then we thought of that, okay, the model that we have trained at UMBC, let us try to also implement it on the data set from India. And we were searching for a partner, and finally, thanks to this TIH funding from ISI Kolkata and our collaborator at IIT Jodhpur, we have been able to create a collaboration with AIIMS Jodhpur. And AIIMS Jodhpur has their neurological department, which also maintains such kind of rehabilitation center for the dementia patients. And there were approximately 30 patients. We had a hard time there to do this experiment because there are a lot of ethical issues that were concerning, and we had to take ethical clearance from different levels, from AIIMS, from IIT, also from the ministry level. After doing that, last year, we are finally been able to deploy this model to the patients at AIIMS Jodhpur. And our surprise, we found that the model which was working with almost 90%, more than 90% accuracy, 98, 99% accuracy at USA, at UMBC Nursing School. When we deployed that model to this AIIMS Jodhpur, its accuracy dropped to even less than 50%. Okay, so it was a complete random sampling, and we tried to look into that, what could actually make this model fail in this instance. And interestingly, what we observed that what happened, that these activity patterns are very different in case of USA and in case of India. Okay, so whatever we have been identified as pivot in case of USA, that pivot didn't work in case of India. Okay, so in USA, we have picked up this brushing, then changing cloth, then cooking, those as the pivot. But the pattern of those pivots are very different when we deployed it in India. And because of this pivot mismatch, the semi-supervised learning framework was even not working for the dataset for India. We need to choose new pivot, and we need to retain that even the initial encoding mechanism that we had. Well, then only it worked. So what we understand that having a generic model for different communities, for different people from different countries, it is very hard to be. Okay, you need to particularly to look into community-specific model whenever you are looking into patterns into activities or such kind of things, which has significant regional influence. Well, so getting those kind of generic model is very difficult. Another interesting approach we observed that in many cases, these gestures are overlapping and it creates confusion. It creates confusion in the model. Okay, and we are actually, I mean, this is something we are currently looking into, and we also did some initial deployment of it. That, well, can I know the environment of the person, that where the person is doing that activities, whether it is within bathroom or whether it is within the kitchen or whether it is in the living room. Because the moment I specify the environment, that environment can constrain on the number of activities that we have to look into. Obviously, the activity that you are doing on your living room, the same activity or similar type of activity you are not going to do in your kitchen or in your bathroom. Okay, so the activity spaces are, some of the activities might be a little bit overlapping, but there is a significant of non-overlapping activity across the spaces. So the idea was that can I use the acoustic information? Well, uh, uh, to so use something called acoustic reverberation, well, to identify that in which environment I am doing the activity. And possibly this is something you also observe. Say, for example, if you are doing some sound within a bathroom, and if you are doing the similar type of sound in your living room, it will look little different because of the size of the room. Okay, so that is coming from the reverberation, the reflected signal that is coming from your room furniture or the wall and so on. So our idea was to capture this reverberation, and from there make these kind of models more generic by reducing the search space in the activity classes, so that we can do it kind of more diligently or in a robust way. So that is all about from my side. As I was saying, like the broad idea here was to come up with a smart wearable with on-device computing capability to continuously monitor the activities, and from there to identify the dementia. We have some initial prototype that we have built up and we are testing. But as I said, like we are facing a lot of difficulty due to these changes in the communality, changes in the activity patterns across individuals, okay, the individual regulations at the individual countries. So hopefully we will be able to come up with something in the next few years. Things are moving in a very good progress. And let's see that in which direction we move on further. Well, so that's all about our experience on this project. So finally, I will just take 1 minute to introduce our lab. So the lab that we call here in IIT Kharagpur, we call it as Ubiquitous Network Systems Lab or UBNet. We primarily work on various type of sensors to develop such interesting applications for various type of societal problem, starting from healthcare, environment, sustainability, transport in various domains. And we are having a lot of industry collaboration with various academia across the globe. So if you have any student working who is interested to do a higher study, a PhD, or want to do an internship at our lab, please encourage them to apply. So we have our website, lab website, as well as the LinkedIn and Facebook, as well as Twitter pages. You can scan this barcode to get the details. So please encourage them to apply. They can also visit the lab to see all the systems that we have built up for the different prototype that we have built up. And hopefully that will be an enriching experience for them. And we have a lot of open positions right now. We are actively looking for good students. So that is a message for all of you. With that, I will stop here. If we have any further questions, we'll be happy to take them up. Thank you.
Thank you very much, sir, for this technically rich presentation addressing the alarming disease that is getting increasingly that is means getting increased.
Yeah. So I see.
Ma'am, you are
so
muted.
there are any question? Yeah.
Ma'am, you are muted.
Oh, sorry. Thank you so much, sir. Actually, you have addressed the disease that is alarmingly increasing, specifically in the elderly people, irrespective of the demography and the irrespective of the country, anywhere in the world. And this needs to be, it's a cry of this hour that this needs to be addressed in proper time. So now the interactive session is open. So you may please ask your question.
Hello, sir.
Yeah,
I'm
please go ahead.
Shantanu. Sir, actually, I was a little bit curious about. So there are few cognitive tested, like physical tested, like tests like clock drawing test that is
Mhm.
actually done with the to identify this kind of patient. So is that kind of activity can somehow be integrated with your system?
Yes, see, the thing is that there are various type of cognitive tests that are being done at the doctor's level. But if you look into carefully those tests, none of those tests are actually concluding enough. And that is the reason that to correctly identify a dementia patient, you need to go through multiple such round of tests. And so some of the tests that we have also incorporated, like slums and others, again, with one round of such kind of test, you cannot definitely say whether a person has dementia or not. So typically what the doctor does, that whenever you are going to visit the doctor will prescribe some test, you have to do it. The doctor will see the result. Then again, the doctor will say that you have to do it after 1 month. Again, you do the same test. They will basically compare the result of the test. For a single test result, there is no concluding view that someone can derive. So that way, there are 5 or 6 rounds of such kind of test that the doctor does to confirm that the patient has certain level of dementia. Right? So that is the main challenge. And typically for the patients that we have recruited for our experiment, both in USA as well as in India, they have already went through such kind of test. Well, because we also need the information about that. So to build up the model, build up the stuffs, we also need such kind of ground truth information. So the ground truth information have actually been collected through this method. So it is not like that we have just picked up some people and did this. And there are very interesting aspect also. So I can just share the story if Dr. Suparna give me some time. So the thing is that, so whenever we are doing these experiments
Yes,
at
sir.
yeah, sure. So whenever we are doing these experiments at USA as well as in AIMS, we had taken the samples from the rehabilitation center who have already been detected as dementia, and they were our positive samples. And then we recruited some normal people. Say, for example, we have recruited some old people from AIMS, not AIMS, from IIT Jodhpur, some people from IIT Kharagpur. Then in USA also we have taken some old people, and we thought that, well, they have not been diagnosed with dementia, so they will be our negative samples, like they will the normal people. But when we were performing the experiments, we suddenly found out that, okay, some of them, around 10 to 20% of them, actually showed symptoms of dementia. And then we have sent those people to the doctors that you please, not all, everyone was not convinced. That was another interesting story. So when we told people that, hey, it seems, obviously we have not told the person directly, but we have told to their people in their home that, hey, possibly your father has symptoms of dementia. Okay, you should take your father to the doctor and do a checkup. Quite a few people just simply denied. Well, they say that no, my father is normal, and they have not done any test till now, at least I know. But there are some cases where people have taken it seriously, and they have taken their father or mother to the doctor, did the test, and after 6 months, they came back to us and they told us, you are right. The doctor said that the person has mild cognitive impairment or say early cognitive impairment. Well, so while we actually tried to test this system with the people, even there are some cases which are not originally diagnosed by the doctors. They have not went to the doctor yet, but through this process, they have been diagnosed with dementia. So this kind of things actually happened. And what we believe that if we can come up with such kind of low-cost device, and it is not very safe. For example, for the older people nowadays, we also want to monitor the old people. We want to track their movement. Okay, many of the people for our say father or mother, we are buying such kind of uh, smart bands. Well, these are not that popular in India yet, but in US or other countries, it is already very popular. People use it very regularly. Now, if we can also incorporate such kind of features there, that the smart band is tracking you, good, but at the same time, it is also monitoring your behavior, and it has been able to tell you that you have these early symptoms of dementia or mild symptoms of dementia, then possibly that 6 months time that you will waste on doing all these medical tests, not only the time but also the money that you are going to save. Okay, so that way it can actually help in practical life. Yeah. Any other query?
Thank you for your elaboration. So, any further question?
So I also want to ask another thing that
Sure.
your solution seems to be very good, but I feel it may have some more challenges because dementia, finding the patient of dementia actually is a multi-factor things, not a single.
Absolutely. Means, as I have said, like we are still in the process of building it up. It is not kind of 100% correct yet. Well, and as I have said, like, see, for the US, it worked good. Well, but in India, it was severely challenging. Well, because of our lifestyle, because of kind of our societal constraints that we have. Well, we are actually means having a means even I will say like a couple of weeks back we had a long session with the doctors from AIMS that actually to debate on this, that what type of information do I need to actually identify it in the Indian context. Okay, because lifestyle alone or activity alone cannot give me the whole information about identifying dementia. Right? So there are various factors. One interesting factor that came up, say, it actually we observed during this winter at Delhi, that this pollution level that impacts the cognitive capability of individuals. Okay, so that way, the dementia patient, they shows more instances of anomalies in their behavior during this winter time when the air is polluted. Okay, so such kind of interesting facts keeps on coming, and we are trying our best to incorporate them. As I have said, like it is not fully successful yet. Well, but I mean, there is a long way to go. But let us see. But given that we are different type of uh, things are getting penetrated, so it might not be accelerometer alone. We might also need certain other type of physiological signatures. Okay, that might also help. We can incorporate them with the information that we are getting from accelerometer to build up the final solution. Well, so it is just like as I have said, it is a large team. We are looking into various aspects, and let's see where we can land after a few years. Yeah.
Yes, sir. And there is, sir, too, with our generation, there is also, even not with us also, even for our younger one also, not for the elder, it doesn't. They are more prone to habit change. They go for different habit change activities, like change in their diet, change in their specific activity. One fine morning they started like
Exactly. So, exactly
yoga.
that is the thing, Shantini. So the thing is that intentional changes and unintentional changes has different patterns. Okay, so that is the kind of core in our idea that whenever you will have an intentional changes, well, that intentional change not only will have a change, but it will persist. So, for example, that thing that you have said, that diet change. Well, so if I change my diet willingly, that will persist for some days, right? But for dementia people, what we will see that it is all of a sudden. So suddenly, the examples that I was giving, that they are brushing their hair, only suddenly you will see that they have not brushing, they are combing their hair. Suddenly you will see that they have gone from left to right instead of right to left. But on the next day, they will again go back to that right to left. Okay, so that kind of anomalies that happen in their behavior, and these anomalies are the key point to see that whether it is uh, intentional changes in the behavior or something like an anomaly. And that is the entire kind of, if I tell you the problem statement is exactly to separate out the anomaly from the intentional changes.
Okay, sir. Thank you, sir.
Okay.
Sir,
Yeah.
yeah. Good evening, sir.
Good
So
evening.
yesterday, one of our speaker who was from TCS, she was telling about using the radar technology to monitor the movements
Right.
inside
Right.
the house.
Mhm.
So whether that can be implemented inside
Absolutely,
this.
absolutely. Means so we also, I mean, I have not talked it here. So if I just go back to my previous slide, uh, yeah. So here at the right hand side, just on top of the UBNet logo, the device that you are observing, that is actually a radar, a millimeter wave radar. Okay, so this radar we have built up for continuous monitoring of human activities in indoor environment, in indoor spaces, and particularly to handle multi-user activities, not only to monitor a single user. But in the current context, the challenge, or if I say the practical deployment challenges, the practical technology-wise, obviously, it is a much robust solution to identify the activity compared to the accelerometer data that we are calling. But if you think about the cost of the devices, so a smart band today, it will cost you 2,000 to 3,000 rupees. Well, a simple smart band. But this radar, it cost around 60,000, the low cost radars, 40 to 60,000. And then along with that, I need some other ports to capture the data, to process the data, and so on. So this entire system that you can see here in this diagram, that entire system cost us around 1.5 lakh rupees. Okay. So this is the trade-off in the current context. So if tomorrow your radar cost goes down or you move towards that kind of environment, obviously it can help. As I have said, like radars have much more better perception in understanding the human activities. It can monitor in much more granularity, but you have this kind of cost benefit trade-off. Your cost is much higher compared to a smart band.
Okay, sir. Thank you. Thank you so much.
Any more question? Or otherwise, we will share email ID of Dr. Sandeep Chakraborty for offline interaction, because this topic is of real interest and real application for societal benefit. And so can
So
we consider?
just
Yeah.
sorry to interrupt, you can just scan this QR code. It has all the information about our lab where you can see all the projects that we are running currently. It's details. There are many videos of the different systems and tools that we have built up. And also the contact details, everything is there. So just feel free to contact me if you are interested.
Thank you. Thank you so much for providing all the necessary information to the participants who can, from their own interest, can continue this with and can sought your help or your expertise as per their requirements. So with this, on behalf of the organizing committee, I would extend my sincere thanks and gratitude to you that in spite of your busy schedule, you have spent this time and illuminated all of us with this wonderful session on this alarming issue. So thank you once again and look forward in future endeavors as well. So
Thank you. Thanks for inviting, and thanks to all the participants for attending this session. So yeah, so please feel free to reach me if you have any doubt, anything you want to discuss further. Thank you.
yes. So with this, all the technical sessions, 13 sessions during this last 6 days from 3rd February to 8th February, we have tried our best, the team actually. Myself, Dr. Suparna Vishwas, Dr. Sohail Saif as coordinator and co-coordinators, the computer operator and technical support team, Ms. Shumana Chakraborty and Mr. Shubhashish Sengupta. We have tried our best to answer all your queries, to attend all your needs as and when related to the technical sessions, maybe related to your attendance, link issues, whatever, so on and so forth. So with this, we come to the end of the technical sessions, and all the dignitaries for this valedictory session are already amongst us. I welcome on the behalf of organizing committee, I welcome all of you, sir. And first, we will listen from Dr. Indranil Mukherjee, Professor Indranil Mukherjee, Director of Academic Affairs. Sir, welcome you, and please say a few words as we are almost at the end of this 6 days long FDP program.
Very good evening to all of you. Many thanks to Dr. Suparna Biswas and Dr. Sohail Saif for conducting this online faculty development program on a very, very interesting topic. In fact, when Professor Sandeep Chakraborty was answering questions and deliberating, I was listening with rapt attention to him, because I had a very close relative of mine, very, very close, who was a dementia patient. She passed away only just last month, 14th of last month. So I have seen her suffer from very close quarters. So this is a topic which really touched my heart. So thank you, Suparna, and I am sure that professors like Professor Sandeep Chakraborty, others, Suparna, Sohail, all of you will take a leading role in exploring different aspects of this disease, and what this particular FDP and the associated research brings us to is that today we are really concerned with problem solving. And to solve problems, we need to collect together people from diverse backgrounds. That could be computer science, that could be social science, that could be management science, that could be mathematical science, and so on. So at the end of the day, the problems will belong to different domains, diverse domains, and scientists, technologists, thought leaders, social scientists, all of them will come together to address these concerns for the betterment of humanity and for a better planet. Thank you once again. My sincere thanks to all the resource persons, all the dignitaries. I thank all of you on behalf of our university, and of course the participants, the students, the recipients who interacted with the resource persons. And I am sure that we will have a very tangible outcome from here. Thank you.
Thank you, sir, for your kind words and for your time to join this valedictory session. And I would like to welcome Dr. T.S. Sinha, Director of the Computer Science and Engineering. Sir.
Good evening, madam. Good evening, everybody. It's a great privilege. I have seen that the last moment when Sandeep sir was giving his presentation under ubiquitous computing and the applications of that in various areas. I'm really, sir, thankful to you that you are doing a lot of research in this area. I hope the participants who are attending this, definitely they will be going further for their research work. It is a good and really a great challenging research work where ubiquitous computing, Internet of Things with, that is thinking style. That is the main thing where ubiquitous computing, anywhere you can do. So it's a lot of things where we are also linked with that key when we are searching in this area, that ubiquitous computing, there is some drawback which is to be very, very a challenging one, because privacy is the main part of the data. Right, sir? Sandeep, sir?
Yeah, absolutely. See, privacy as well as the way data need to be processed.
Right.
Because I can just give you one example. So we are doing one of the participants were asking for this radar-based approach of human behavior monitoring and all those stuffs. So this Google in their Pixel version 4, Google Pixel 4, they had actually enabled this radar-based human monitoring or radar-based environmental monitoring. But then immediately after releasing that version of Google Pixel 4, there were a lot of complaints that keep on coming that, okay, with that version of the phone, you are supposed to monitor, say, your physical behavior or certain things, but people are eavesdropping on others. So the radar can monitor even your fine movement in hands, and that way, whenever you are typing something on your keyboard, that can also be monitored by another person if that person uses a radar technology. So consequently, say you are submitting your password to your banking website, people can infer that what password you have typed. Right? So that kind of concern came up, and then from Google Pixel 5 onwards, Google have actually not allowed people to get direct access to the MMO band for using sensing. So that way, lots of such different security, privacy challenges that keeps on coming. And as you understand that there is always a trade-off. Well, so what I believe that if we want to get some service, we have to give something. So for example, now we get a lot of different things from Google, and in turn, possibly Google knows everything about us, what we are doing, where we are moving, they know everything. Okay, so that's the kind of trade-off anyway we need to kind of bring to our society and need to see that what can be the best usage for a particular technology while ensuring this privacy, security, such kind of guarantee.
Thank you, sir. Thank you very much, sir. I hope the participants were very much explored with the new technology and the areas of our whatever the topic has been covered by so many resource persons. So thank you, madam, and thank you, Sohel sir, and thank you, sir. Thank you, Sandeep sir, and other resource persons. I hope the participants got a lot of knowledge from this. Thank you once again. Please, thank you, madam.
Thank you so much, sir. Now, Director of SIST, Nabarun sir, are you here?
Yeah. Can you
Yeah.
listen to me?
Yes, yes.
So, thank you, Suparna. Thank you, organizers. And I, on behalf of university and our school, I extend the heartiest thanks and gratitude to all the resource persons. I understand 13 lectures in 6 days and very high quality lectures. I have heard a few, including the last one. And definitely these kind of FDP and a lot of participants also I can see. So very successful FDP could be concluded very gracefully in presence of so many participants. So only since this is the valedictory session, I'll urge everybody that MAKAUT has organized this FDP. Now the collaborations, the platform for collaboration is open, not only for MAKAUT, but for all the participants to really establish meaningful link with the resource persons, and the research in the most advanced topics have been discussed. So we can really take a lot of clues, all of us, and take the research forward. With these words, I once again wish all the best to all the participants and once again express my deep gratitude to the resource persons who delivered. Thank you very much. Suparna, you are muted.
Oh, sorry, sir. Thank you, sir. Thank you so much for your kind words. I would be happy to share that the kind words and inspiring words from our Honorable Vice Chancellor, sir, has reached to me, and due to some pre-assigned tasks, he is not able to join the valedictory session, but he has conveyed his best wishes to the organizing team. So next, we would like to hear a few words from Dr. Shoikat Basu, HOD CSE. Can you hear, Dr. Basu? maybe in a network issue. So I would like to welcome Dr. Pritam Pal, HOD, Computer Application.
It's Pavitra. Yeah. Good evening.
Sorry, very
Okay.
sorry.
So, no, basically, okay, I would like to thank you basically Dr. Shivana Viswas and Dr. Suhail Saib for organizing this 6-day LPP in the current scenario where basically AI basically take over the all over the world, you could say. Okay, so and obviously I would like to express my sincere gratitude to my all our resource persons without whom we are not able to just organize this type of the FDP would not going to success, and obviously the attendee without whom we are not able to just not only the lecture would not be get the success without whom basically attendee get the and not only the attendee obviously they are continuous and attention with the particular lecture that makes our this FDP great success. Hope so. Thank you all for just making our FDP a grand success, and in near future hope to already announced that told the collaboration will give the better opportunity for the all. Thank you. Thank you.
Thank you. So next, Dr. Sohail Saif will extend vote of thanks. Dr. Saif? Hello? Hello? Dr. Sohail Saif, can you hear me?
Am I audible? Hello.
Yes, yes, yes.
Okay. So respected dignitaries, esteemed speakers, faculty members, and dear participants. So as we conclude this 6-day faculty development program on AI in precision agriculture and healthcare on Society 5.0. So it is my great honor to privilege to extend a great heartfelt thank to everybody who contributed to making this event a. So first and foremost, we must express our sincere gratitude to the AICT Training and Learning Academy, that ATAL, for their generous funding support to conduct this HOT, to conduct this FDP. And I must extend our deepest thanks to our Honorable Vice Chancellor, Sir, of Maulana Abul Kalam, Azad University of Technology, West Bengal, for granting the necessary approval and extending his continuous encouragement and support for organizing this kind of events. So my special appreciation is for the registrar of the university for providing the essential administrative support and which ensured the seamless execution of this event. And next, I would like to thank our finance officer for handling all financial related matters related to this FDP. Next, I would like to appreciate the efforts from our information scientist for widely circulating the FDP brochures throughout the university website and other social media platforms. And I must also acknowledge I thank also the Director of Academic Affairs, the Director of School of Computer Science and Engineering, Director of School of Information Science and Technology for their guidance and unwavering support for organizing this kind of event. I also a special note of appreciation for the HOD of Computer Science and Engineering, HOD Computer Applications, for all the esteemed other faculty members of the board departments for their active participativeness, involvement, and coordination throughout this FDP. My to the all esteemed speakers who took their valuable time and delivered these knowledge shareable sessions. So for this smooth conduction of the FDP, and thanks to our technical support team Mr. Subhasis Sengupta and Sumana Sarkar madam, who really worked hard behind the scenes. And last but certainly not the least, my heartfelt gratitude to all participants for their enthusiastic engagement, insightful discussions, and the support and the unwavering commitment throughout these 6 days that your active participation has made the FDP really truly meaningful and impactful. I really thank you all. And once again, thank you for your valuable contribution. And we look forward for more academic collaboration and knowledge sharing endeavors in the future. So thank you and all the best. Thank you.
Thank you, Dr. Saif. So now it's the most weighted event, that is the examination time. And the exam link is being shared in the chat box. Please copy it because after the session ends, the link will not be with you. So you please check the chat box and copy the link, and the link will be valid. To avoid any link or device related problems, you take precautionary measure, and do not fail to fill the examinations, take the examinations or complete the examination by 9:30 p.m. today. So that is the last deadline, and after that the team will not be able to reopen the link. So please be aware of that, and it's very much sufficient time that we are providing to avoid any link or any device related problem. So while we are at the very end of this 6 days online ATAL FDP program, I take this opportunity to extend the thanks and thanks to the ATAL organizing ATAL project that has been planned to give or extend support to organize such kind of faculty development programs in online mode, so that more and more participants can join irrespective of the boundaries, maybe all over the India and outside of India as well. So, and the speakers are also, they have in this current scheme of ATAL, they have given the guidance that the speakers should be from India and abroad, from academia and industry. So this combination, I feel, has made these kind of programs more complete. I have, means our department has organized another ATAL FDP program earlier. I was the coordinator of that program. That time, these kind of strict guidelines was not there. This time, this guideline is given, and we have planned the FDP accordingly. And we are very much thankful to the distinguished speakers of 13 sessions, that it was a precondition of ATAL that there should not be any change in speaker list, and any change cannot be entertained by the ATAL. So, and all are distinguished speaker, in spite of their very much busy schedule, different tasks, assignments. So all of them have committed, remained committed to their date and time and topic. And really thankful to them. And all dear participants, every day you have actively attended the program. And today, yes, it is a rigorous schedule from 2 p.m. It's Saturday, and it's 2 p.m. to till now 7 p.m. and now you need to take the exam. So without wasting much time, we will conclude the FDP over here. And I extend the thanks to the team, total team, the departments of CSE, Department of CA, the co-coordinator Dr. Saif, and the technical team who are relentlessly working behind the scenes. So, and thank you all. So here with the good words, best wishes and good night. And all participants, do not fail to complete the exam, because that is the last formality to get the certificate.
Just one thing to mention, that
Yes.
many participants are writing about the attendance issue. So let me make that confusion very much clear that we have not, the final attendance has been not submitted yet. So after the completion only, we can submit the final attendance. And that is not related with the examination. So you can all appear for the examination, and that is not related with the attendance. So examination can be only done through the Google form only, and that we will upload those marks in that portal. So no need to be confused, just appear for the examination, and we will update that valid attendance by the completion of this FDP. Thank you.
And also the WhatsApp group created for this FDP will be alive for now, unless and until all the formalities are complete in ATAL portal. So no need to worry, no need to panic, and our coordinators' details are with you. In spite of all the measures that we have taken,
Yeah,
if there is any issue, please need to contact. Yeah, so everybody has, I guess everybody has copied the exam link given in the chat box.
So at the last, can everyone please turn on their video? I want to just take one snapshot of the last session. So requesting everybody to turn on their camera so I can take one quick snapshot.
Before that, can I have a small query.
Yeah, please, please go ahead.
Okay, so I have attended one FDP program through ATAL portal. There, I have to give the feedback inside the ATAL portal. Then after we got the certificate from ATAL portal only. So whether that procedure will be same here or something different?
After we upload your attendance, you will have the option to give your feedback also.
Okay, thank you.
So
feedback is taken day wise, so that are with us for record, and in the portal you will be able to give the feedback, final feedback, that is after this update. Per day our feedback are taken, and that is the record with us. Okay, so please keep on your camera so that we can take a screenshot.
It's just in progress. Just a minute. Okay, it's done. Thank you.
So I think all of you have copied the exam link. So now, sir, just we are waiting for 5 minutes so that the participants can copy the link, and we are just waiting for 5 minutes before we close. Dr. Saif, can you please give the message in group also? That exam link is given in chat box, and
I am giving that message.
Yeah, and the session is
chat. The link is also given in the group also. So
okay. Oh, in group also, then that's fine. Then we can, then the session could be ended, right?
Yes, the session could be ended.
The session could be ended. Okay. Okay, thank you all.
Thank you, madam.
Yeah, and thank you, Sohel. Actually, the first initiative or the proposal came from Sohel actually to submit this FDP proposal, if we can apply for this fund and the opportunity. And he has taken relentless effort, has put and taken like background works and continuous these 6 days session arrangements, session management, and background communication with the participants along with the technical team. Actually, he has headed the nitty and gritty of this program. So I congratulate you.
Thank you very much, madam.
Yeah.
So from the behalf of all participants, I am also I would like to also say something that thank you, Supana ma'am, Sohel sir, and all the technical team of yours.
Yes, participants, you can unmute and you can share your thoughts. Who wants? 2 or 3, not much, because for time we may cut short because you have to give the exam also. Participants, if anyone wants, can unmute. So Dr. Dev Shankar Shekhar Laha,
Yes,
please
sir.
continue. Yeah.
So thank you once again. It was a great experience, and the topics I have heard, those are really interesting. I found so many new ideas from those, and thank you once again. Thanks to you, Soil sir, and your technical team and MAKAUT. Thank you.
Yeah, and the sessions were interactive, and you have interacted a lot during lot many sessions. Thank you for that. So, any other participant who want to share your thoughts?
Madam, it's a wonderful session, madam. I appreciated your entire efforts, entire team efforts. Good job, madam.
Sir, could you please introduce yourself?
Actually, this is Dr. Jagdish from KL University, Andhra Pradesh. Good. So, it's a gratitude towards your sincere efforts regarding the agricultural related IoT topic. I'm really immense pleasure to express gratitude towards every team member in your organizers. So, I would like to thank everyone. Congratulations, madam. Thank you.
Thank you so much. Anyone else?
Hello, madam. I am Dr. Ramesh Shah from Triple IT Sanipat. It is very helpful session. I find out lots of new idea regarding the next upcoming technology, that's Industry 5.0, regarding agriculture and healthcare. And thanks to you and Sohel also.
Thank you. And I am proud to say that you are the alumni of our university, our department, and my PhD scholar.
Thank
So
you, ma'am.
thanks
Thank you.
for your feedback. So anyone else?
Good evening, ma'am.
Yes,
Ma'am,
yes.
yeah,
Good evening, sir. Good evening, sir.
ma'am, myself Ramesh from KL University, Andhra Pradesh, ma'am. I'm very thankful for the organizers and you, ma'am. You have planned everything very systematically so that it creates an interest among ourselves to learn the new concepts from the speakers. Thank you, ma'am. And it helps us to move towards the research concepts, what we have learned, and it raises scope for us to do a research on the new technologies. Thank you very much, ma'am.
Thank you so much, sir, for sharing your positive thoughts. It would inspire us for future projects, and we would like to have you in future projects as well. And your all data sheet will be with us. So for next programs, you will surely be communicated. Thank you so much. Anyone else? Okay. So the 6 days FDP program finally comes to the conclusion, not end, because this is the beginning for future and sustainable collaborative works amongst the participants who are distinguished researchers, distinguished academicians in their own fields, in own positions. So we all can collaborate amongst us as per our field of expertise, and also the distinguished speakers are there whom we can connect offline as well. So with these words, again extending thanks to the ATAL, FDP, AICT ATAL Academy, and our university for providing us all the required support for conducting this FDP. And last but not the least, all the best wishes to the dear participants. Good night. So
Right.
can
Thank
we
you.
end? Yeah.
Yes, we can end. The recording can be stopped.
Yeah. So any participant